ओके. तर युट्यूब झालं चालू. तिकडून दुसऱ्यांना सांगा बरं युट्यूबला चालू करून घ्या म्हणून. कोणाला तरी फोन करा. युट्यूब चालू झालेलं युट्यूबवर मी दिसेल ना. मी मुद्दाम त्याला हे करून ठेवलं, ऑफ करून ठेवलं कारण डबल आवाज. हॅलो. एखादं कोणाला तरी युट्यूब पत्र मिळतात ते युट्यूबला हे चालू करायला नाही. तुमच्याला सगळंच चाललं. हा ना ते दुसऱ्याने हाताळलं ना एक युट्यूब लिंक चालू करा. युट्यूब चेक करून सांगा. आवाज येतो. पाठवलेली आहे ना सगळ्यांना टाक. सगळ्यांना असं पाठवलेलं असं तुमचं व्हॉट्सअप ग्रुप चेक करा. सगळ्यांना पाठवलेलं आहे ना असं नाही. पाहतो मी आपली माहिती करून घेत चालायचे की इथे काय काय आलेलं वाचत नाही. काम करणारी येडा होतो असं. आम्हाला माहिती आहे ना काय कुठं काय असतं कुठं काय नसतं. बॅकग्राऊंड सेटिंग. हॅलो. आवाज
हॅलो 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 थोडा आवाज कमी येतो. हॅलो 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 तुमचा आवाज मोठा हॅलो हॅलो आवाज कमी येतो. हॅलो 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 काय अडचण नाही.
हॅलो. कोणाला आवाज द्यायचा माहिती का सर? हा आवाज आहे ना आपल्याला आपला आवाज नाही ऐकायला येत हे लक्षात घ्या. आता हा युट्यूबचा आवाज रिटर्न येतोय आपल्याला. आता मी युट्यूब इथं ऑन ठेवलेलं आहे म्हणून मी हा जर स्पीकर ऑफ केला तर लोकांचा स्पीकर ऑफ होत नाही हे आहे म्हणून युट्यूब कोणतरी चालू करा.
हॅलो हॅलो स्पष्ट मोठा. हॅलो, मोठा आवाज येतो ना? काय हरकत नाही. ओके सर, थँक्यू थँक्यू.
फक्त बोलत राहा. बाहेर काय होतं तर मलाही कळतं. चालू करा. आवाज काल साडेचार पासून सगळं check करून. हो त्यांना बोलतो मी. आमचा एक पेड आहे म्हणे लक्ष्मी कोणी. नाही त्याला तर काही देत नाही. त्याला तुमचं कमी सर्व सांगितलं ना. आणि त्याला कशी देतात त्याच्याकडेच घेऊन मग त्याला त्यालाच शिकवलं त्याला तो बसणार आहे ना. क्रेडिट कार्ड माझं वापरून त्यांना पैसे टाकून मला सर्व त्याच्याकडे फोन केला तुमचा फोन आमच्या मित्र युट्यूब चालू करा लिंक पाठवली ती
This is clear. मग तुमच्या वेळेला तुम्ही
दिवशी घ्या तुम्ही पाटीलचं गाडी
बोला सर,
कसं
बोला.
काय
PN पाटील सर
येत
बोला.
नाही ना?
ते माझं mute करून घ्या.
आली सर, आली आमची.
चित्र कसं वाटतं पहा बरं PN पाटील सरांचं.
अहो एकदम आउटस्टँडिंग कॅमेरा
हा,
क्वालिटी बरोबर असते.
म्हणजे नाही ते परिचय करून देतानाची ठीक केलं ते.
बॅकग्राऊंड बदला म्हणा, पोझिशन बदला, बॅकग्राऊंड बदला.
बॅकग्राऊंड बदला कसं काय बदलायचं होते आता.
बॅकग्राऊंडला ना तुम्ही पोझिशन घ्या.
नाही तुम्ही इकडे सारखा.
एक मिनिट फक्त फिरते camera.
नाही बरं का मी काय म्हणतो हे जी खिडकी येऊ राहिली ना
खिडकी द्या खिडकीचं काही नाही. ते करत आहे ना.
स्क्रीन शेअर करणे शोधणे आणि गॅलरी शोमा व्हिडिओ ब्रँड शोधणे मीटिंग टॉपिक प्ले मी आणि रिने च्या
शेअर केलेला आहे.
ब्लॉक नाही.
हॅलो सर, माझा आवाज येतो का?
हो
आवाज येतोय.
येतो मला आवाज?
माझं स्क्रीन
ते बोलतो आवाज येतो का?
हा
हो आवाज येतो ना.
हा
येतो आवाज. आवाज येतोय तुमचा. आवाज येतोय तुमचा.
मी काय म्हणतो
हा येतोय ना आवाज. येतोय आवाज.
तुमचा आवाज येतोय.
मी आता अनम्यूट होऊ का? अनम्यूट होऊ का?
हा अनम्यूट व्हा.
पाटील सर.
अनम्यूटच आहे मी आता. अनम्यूटच आहे मी आता. अनम्यूट कसं? हे काय सर अनम्यूट होऊ.
बरोबर ना अनम्यूट झाले तुम्ही.
बस ना.
बॅकग्राऊंड सिलेक्ट करता येतं ना आपल्याला. हॅलो हॅलो.
बर आता माझा आवाज येतो का? आपण मग तुमचा नाही येत ना. तुमचा नाही. तुमचा आवाज येतो.
तुम्ही बोलताय का.
हा तुमचा आवाज आहे ना.
हॅलो.
हा आता येतोय.
हॅलो हॅलो.
युट्यूबला आवाज येत नाही का.
युट्यूबला नाही याला.
आला ना आता आला ना. आता आला ना.
हॅलो तुम्हाला आलं का याचा
हॅलो.
त्रिभुवनचा
हो
आवाज?
हो हो
हॅलो
हा बोला सर.
नाही येत सर तुमचा आवाज माझ्या मोबाईलवर.
हो नाही आवाज
आता
येतोय मला
सोनवणे सरांच्या मोबाईलवर यायला लागला.
सगळ्यांना येतोय. तुम्ही तुमचं हे करा फक्त
आता येतोय.
हा
सेटिंग
हा
करा.
युअर आहे तुमचं अनम्यूट आहे का बाबर
नाही बा. हॅलो
इकडे इकडे ठेवून घ्या ना
त्रिभुवन सर बोला.
हॅलो.
हा आला
ती खुर्ची वर घे
आला आला.
उशी उशी
हा इकडे तुम्ही ते एकमेकाजवळ येत आहे बरं का.
नाही नाही बोलतो आपण 3 जणांनी चालू केलं म्हणून. हॅलो
म्यूट करू का?
जाधव सर.
आता नाही येणार
जाधव सर.
हे कसं हे बॅकग्राऊंड चांगलं आलं ते खिडकी
जाधव
जवळ
सर. तेरा पार्टिसिपंट्स झाले भाऊ. अजून 10 मिनिटं वेळ आहे.
हॅलो.
हॅलो सर. हॅलो 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 हॅलो,
दादा सर आवाज येतोय तुमचा?
येतो आवाज येतो ना?
हो. थोडं थोडं जवळ घ्या माईक.
हा जवळ, एकदम जवळ आहे सर, एकदम mic जवळ.
बारीक बारीक आवाज येतोय.
माझा
ओके ओके.
म्हणून सर
हा
आवाज कसा येतो?
आता बरं आहे. आता
आवाज
बरं
येतोय
आहे,
माझा?
आता बरं आहे. हो 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 हो.
हा विवेक पाटील कुठं ओढ्याला जाऊन बसलाय, पाणी दिसतं मागे. हा का रे, काल कुठं होता? काल कुठं होता आमच्या वेबिनार? अरे तू ऑडिबल नाही ना, तू पाटील, तू ऑडिबल नाही, तुझा स्पीकर ऑन कर ना.
हा हा बोल.
काल कुठं जाऊन बसला होता? आज ओढ्याला जाऊन बसला तू?
काल वाटायलाच होतो ना. काल आहे ना काल तू शुद्धीत काल तू शुद्धीत काल तू शुद्धीत नव्हता ना.
असं आहे का? बरोबर.
त्याच्यामुळे तो काल होता आज तू.
शुद्धीत तू होता का काल? शुद्धीत होता?
मग
बरं आज दोघही शुद्धी ते
तुला काल
चल
काम
ना.
होतं.
करा, चालू करा मीटिंग.
हा हा झाले, शाहजूक झाले का?
Jadhav sir, you are looking smart. So smart.
वाचोर सर,
हा.
आज पुन्हा आपलंच एक जाधव सरांचं.
नाही जाधव सरांना, जाधव सरांना शुभेच्छा देऊ ना, शुभेच्छा.
स्वतः शुभेच्छांची खाण आहे, फक्त वाटायला जीव काढतो एवढंच.
सर काल खूप छान झालं.
ओके ओके, थँक्यू.
ऑडिशन बंद आहे, आमच्या याच्यावर आवाज होता तुमचा. आता आता
वा PN पाटील साहेब, काय मुद्रा आहे.
धन्यवाद सर.
PN पाटलांना काय धोका नाही. जंगली महाराज, मुक्तानंद महाराज, रुबाई,
हे सगळं मगरची खूप आहे.
साक्षात पाठीमाग.
हा, साक्षात पाठीमाग सर, माऊली बसलेल्या बाहेर पाठीमागे.
घेतला की 1%
हो हो
घेतला.
आला. हॅलो हॅलो त्रिभुवन सर हॅलो
हा सर, यू आर ऑडिबल सर, यू आर ऑडिबल.
येस ओके ओके हॅलो त्रिभुवन सरांशी काय कॉन्टॅक्ट होत नाही.
हॅलो गोस्वामी सर.
हा सर.
त्रिभुवन सर, जाधव सर म्यूट आहे बघा.
नाही ते एक माईक वापरणार आहेत, कारण त्यांचं माईक चालू केलं तर इकडे विस्लिंग येतो, इको येतो.
हा त्रिभुवन सर.
हा बोला. हॅलो.
हा येतोय ना आवाज?
हा तुमचा आवाज येतोय.
हॅलो.
तुमचा आवाज येतोय मला.
येतोय ना?
हो येतोय.
माझा येतोय की नाही?
येतोय येतोय, तुमचा आवाज
येतोय, तुमचा येतोय, काय हरकत नाही. ओके. हॅलो. हॅलो.
गुड मॉर्निंग डॉक्टर गोस्वामी.
गुड मॉर्निंग गुड मॉर्निंग. थोडा कमी करा, कमी करा. हॅलो.
मॉर्निंग सर. गुड मॉर्निंग कापडणे.
गुड मॉर्निंग सर.
थँक्यू गुड मॉर्निंग. काय म्हणता सोनू गुरुजी? गुड मॉर्निंग.
काय आता
विवेक कुठे शेतात बसलाय?
विवेक
शेतात बसलाय.
आहे इथंच आहे.
कापडणे सर गुड मॉर्निंग अँड वेलकम. गुड मॉर्निंग गुड मॉर्निंग. मागे सगळं कलरफुल दिसतं, मला वाटलं शेतात देतात एक काय म्हटलं.
ओढेला.
अरे बाबा, नको त्या गोष्टी नको दिसायला.
याच्यामुळे झाकलं जात.
त्रिभुवन सर.
जैन कदम.
बंद करून तुमचं आता मी येतो बोलतो. ते काय इको होतं.
अच्छा सर, तुम्ही बसा इथंच खुर्ची. काय टेक्निकल अडचण जर आली ना मग लय अवघड. ते घ्या ना एक खुर्ची, निंबा एक खुर्ची घे इकडे बच्चा सर.
तुमचा आवाज जास्त येतो बरं का.
बोलून घे. निरोप दे.
गोस्वामी सर, तुमचा आवाज जास्त येतो. आवाज
जास्त आहे का? बर, थोडा कमी कर. पाचोरे सर. हॅलो.
हा बोला ना सर.
ओके
ओके ओके.
बस ना का अजून कमी? हा अनम्यूट करा बाकीचे. त्रिभुवन सर.
त्रिभुवन
जाधव सर.
दुकळे सर, मीट युअर सेल्फ.
आता मला परत बदलून करावं लागलं.
बरं ठीक आहे ठीक आहे. हा हा एक मिनिट मी लगेच हा एक मिनिट बघून घेतो मी लगेच सांगतो.
जाधव सर कोण सर? हॅलो.
Good morning, sir. Very good morning.
राहुल गुड मॉर्निंग.
Very good morning, sir. Very good morning.
जाधव सर गुड मॉर्निंग.
Good morning to all of you. Good morning, Mana Sahib.
गुड मॉर्निंग गुड मॉर्निंग.
त्रिभुवन सर केमिस्ट्री आणि तुम्ही सोडून सगळ्यांना म्यूट करून टाका.
सर ठीक आहे जातो.
Are we waiting for some special guest?
No, sir. There is some problem. They can avoid that problem, sir.
The two devices should not be in one room. That is very important. Otherwise, you will get echo. Two mobile phones, one mobile phone or another one is laptop or something. It should not be in one room.
जाधव सर जाधव सर कोणाच तरी दोन मोबाईल जवळ आहे त्याच्यामुळे आवाज येतो इको तयार होतो.
इको येणार त्याच्यामुळे तुम्हाला. एका रूम मध्ये नको. लॅपटॉप आणि मोबाईल सुद्धा नको, नाही तर मग इको येत राहील.
आता वेटिंग कशाची?
Huh?
I don't feel there is any problem.
हॅलो हॅलो माईक चेक हॅलो हॅलो माईक चेक
सर त्रिभुवन सर ऑडिबल नाही ना तुम्ही व्हिडिओबल विजिबल पण नाही ऑडिबल. सर सगळ्यांना म्यूट करा ना तुम्ही. आवाज येतोय का सर?
हॅलो हॅलो माईक चेक हॅलो माईक चेक हॅलो हॅलो सर
सर आवाज येतो बोला.
हॅलो हॅलो माईक चेक हॅलो
सर तो माईक जवळ घ्या सर. माईक जवळ घ्या. माईक जवळ घ्या.
हॅलो
त्याला बंद करून बघा.
चल बंद करा चल बंद करा चल बंद करा.
हा पण माईक चालू होतो.
हॅलो हॅलो माझा आवाज येतो
हा आता येतोय. जाधव सर येतोय.
सर इकडे बस. एक मिनिट सर.
येतोय आवाज येतोय.
हे काय
झालं सर आता ऑडिबल झालं. जाधव सर हाय तिथून करून घ्या. हा
हॅलो हॅलो सर ऑडिबल आहे. हॅलो
नाही आता
हो येतोय सर आवाज. जाधव सर आवाज येतोय.
हा
सुरू करायचं सर?
हो करा करा. तुम्ही व्हिजिबल नाही बरं का पण.
नाही का सर? विजिबल
हे कुठे आहे हो? आहे का व्हिजिबल आहे?
सोनवणे सर
हो बोला सर.
त्यांची स्क्रीन दिसत नाही ना. त्रिभुवन सरांना
हो.
तुम्ही विजिबल नाही दोघं बी.
दोघंही व्हिजिबल नाही
नाही
बरं.
त्रिभुवन त्रिभुवन सर आहेत भाऊ.
त्रिभुवन सर
पाटील
आहे, जाधव सर नाही.
त्रिभुवन सर आहे ना. जाधव सर पण असतील हो.
हॅलो
त्या खुर्चीवर काम करून घेता का आता?
नाही याला नेट लागतो मला. हॅलो
जाधव सरांचा आवाज जरा कमी येतो. आवाज धनवट सर. आवाज येत नाही झाला. नॉट ऑडिबल.
आवाज येतो सर? हॅलो लांब राहावं लागेल. एकाच नाही होणार सर. मायक्रोफोन बंद करा सर. बंद असेल. हॅलो 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 हॅलो
जाधव सर आवाज येतो तुमचा.
आवाज येतोय सर तुमचा. येतो आवाज.
विजिबल आहे सर? मी
यू आर ऑडिबल.
विजिबल आहे सर?
विजिबल ऑडिबल बोथ.
Both are audible as well.
Yes sir.
Yes, you are very clear, sir.
Now we are going to start today's proceeding.
Yeah, continue, sir.
Yes. Ladies and gentlemen, good morning. Professor K.K. Jadhav, Head Department of Chemistry, Swami Muktanand Science College, Evla, is pleased to welcome each and every one of you to a brainstorming webinar on green chemistry. Before going in, I would like to point out two most crucial things which happen on the same day. One of them, as far as Indian democracy is concerned, today, 26th of November, 1949, we have adopted Indian Constitution. And second thing is that, which is a black day, on the same day, 26th of November 2008, that was 12 years ago, a national was devastated by terrorist attack. In this timid attack, near 170 people were killed and 300 wounded. Mumbai police, compared with Scotland Yard police, did combat this terror attack very firmly. During their warrior, they lost policemen like Karkare, Ashok Kamte, Tukaram Umble, Sandeep Unikrishna, like this. Now, on this occasion, it is our moral responsibility to pay moral tribute to the departed people. Let us observe 1 minute silence, please.
गेला आवाज त्यांचा.
Now, proceed further. Pollution is one of the alarming challenge before not only India, but before the entire world. And to find an amicable solution to this alarming challenge, the concept of green chemistry came forward. Green chemistry is nothing but the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substance. Green chemistry applies across the life cycle of chemical products, including design, manufacture, use, and ultimate disposal. Now, we are turning towards our most crucial issue. Before going in, I would like to apprise regarding today's framework of the program. Now, first of all, being the head of Department Chemistry my moral responsibility to apprise regarding my Department of Chemistry. I have great pleasure to apprise my profile of my department. Department of Chemistry was started at TYBSc level in June 1993-94. Initially, we faced many difficulties, but later on, we marched towards tremendous success. 27 years are rolled by, and during this long spell of 27 years, near about 950 students were passed out from our college as a chemistry graduate. I'm proud to say that our departmental alumni, Mr. Vinayak Pagar, who has completed his PhD and postdoc in Taiwan, PhD from Taiwan and postdoc from USA. Second alumni, Amol Sonawne, completed his PhD from Japan.
दादा सर आवाज नहीं आ रही.
And postdoc in USA. Appa Kadam recently joining postdoc in USA. As far as the success of department is concerned, the credit of entire success goes to the sustained efforts, hard work, and unity of our departmental students, my colleagues, and principal and my management. Our management has been supporting to all departments very nicely and correctly. I would like to say that we have achieved a milestone in the academics, but we are not satisfied on this stage. We will march, lot of things has to be achieved in the future. Thank you very much. Now, turn towards next era, or next day of this webinar. May I invite my honorable principal, Dr. Dhanraj Goswami sir, to address to the gathering. Yes, Goswami sir.
Yes. Welcome, everyone. Thank you for joining us for today's webinar on green and clean chemistry. My name is Dr. D.B. Goswami, Principal of Swami Muktananda Science College, Yeola. This webinar is organized by Department of Chemistry and IQC Swami Muktananda Science College, Yeola. This webinar cannot be completed without kind support and encouragement of Honorable Dr. Amrita Pahlwan, President of Sri Gurudev Shikshan Mandal, and Honorable Secretary Sri Deepak Gaikwad, and members of management. I heartily welcome today's speaker, Professor D.K. Rawal from Sardar Patel University, Anand, Gujarat, and Dr. V.P. Gaikwad, Principal, KTHM College, Nasik, and Management Council member of SPPU, Pune. Green chemistry, sustainable human and ecological use and reuse of remediate land, minimize impact to water quality and water resources, reduce air toxics, emissions and greenhouse gas production, minimize material use and waste production of conserve natural resources and energy. It gives me immense pleasure to introduce today's topic to all of you. Hope the webinar introduce today topic to all of you. I hope this webinar will be fruitful and informative to you. Happy National Constitutional Day to all. Thank you, one and all.
Thank you very much for giving nice and brief preface of the college. Now, I would like to invite the chairman of Gurudev Shikshan Pradhak Mandal, Honorable Dr. Amrita Pahlwan, to deliver his inaugural speech. Over to Dr. Amrita Pahlwan.
Good morning to everyone. I would like to extend my warm greeting to you on this beautiful morning. A national webinar is being organized today by Department of Chemistry and IQAC jointly. Being the head of the institution, it's my moral duty to apprise your institution. Shri Gurudev Shikshan Prasarak Mandal Yeola was established in 1974 with 25 students on the board. Initially, we faced many social and physical crises to run the institution. Physical crisis did not become a stumbling block in our way, and now huge tree is flourished, comprising primary, secondary, higher secondary, and senior college unit. The credit of this expansion goes to sustained efforts by the management, moral support, and hard work from staff. Senior college was started by institution in 1991. We achieved many milestones in academics, but still a lot of things are to be achieved yet. I heartily welcome today speaker, Professor D.K. Rawal from Sardar Patel University, Anand, Gujarat, and Principal Dr. V.B. Gaikwad of KTHM College, Nasik, as well as faculties, chemists, researchers, scholars, students for joining national webinar in chemistry. Thanks to Dr. D.B. Goswami, Principal of College, Professor K.K. Jadhav, Head Department of Chemistry, Professor A.P. Tribhuvan, IQAC Coordinator, and all faculties who worked really hard for this program. Thank you everyone for joining us. Thank you. All the best.
Thank you very much, sir, for your nice
Yes, sir.
briefing to the gathering. Now turn towards the first session of the webinar, which we were waiting since long back. In the first session, the resource person is Dr. Deepak Kumar Rawal, Professor in Chemistry from Sardar Vallabhbhai Patel, Vidya Vallabh Nagar, Anand, Gujarat. Before going in, I would like to request my colleagues, Mr. P.N. Patel, to introduce the first resource person. Please, P.N. Patel, sir. P.N. Patel, sir, please. Hello, P.N. Patel. हेलो पीएन पाटिल सर
सब बोलते हैं
यस
पीएन पाटिल कनेक्ट नहीं होती
पीएन पाटिल सर
आपला जाऊ दे मोबाईल आपला मोबाईल जाऊ दे
यस सर गो अहेड प्लीज
पाटील ऑडिबल नाही पीएन पाटील सर
बाकीचे जे पार्टिसिपेंट्स आहेत ना त्यांनी माईक हे करू नका ना ऑन करू नका ना PN Patil sir, unmute yourself and introduce the today's resource person.
Good morning, sir. I have great pleasure to introduce eminent personality for today's national webinar for green and clean chemistry is Professor Dr. D.K. Rawal, sir. Rawal, sir, is working in Sardar Patel University, Vallabh Vidyanagar, Anand, in Department of Chemistry for last 27 years. His educational qualification is MSc in chemistry and PhD. His research area is organic chemistry as well as polymer chemistry. Rawal sir has valuable contribution in organic synthesis. There is 62 publications available in their own name. 19 students have been got PhD under his guidance. Sir has completed 5 minor research projects. Rawal sir has got Best Thesis Award in Sardar Patel University in 1988. In 1990 to 93, Sir has awarded Hariom Asharam Best Research Paper Award. Sir is Fellow of Gujarat Science Academy. He is member of Indian Council of Chemists. He is also life member of Association of Carbohydrate and Techniques. Some of the important highlights of his achievements are as follows. Since 1989, Sir is teaching organic chemistry. He is also member of academic bodies in Sardar Patel University as well as in other many universities. Also, Sir has acted as member on various committees at Sardar Patel University. Rawal sir is in charge head, Department of Pharmaceutical Science since 2010. Also, sir is in charge dean for Faculty of Pharmaceutical Science. Sir is UGC nominee at Nagpur University for SAP program. Sir has delivered invited talks at national conferences and seminars. He also invited and delivered lectures at UGC visiting professors. Rawal sir has organized 3 national seminars at Sardar Patel University. Sir is the member of selection committee at various universities and institutions as well as UPSC and MPSC. Rawal sir is the member of BAPS. With this brief introduction, I request Professor D.K. Rawal to deliver his speech. Thank you. Over to K.K. Jadhav sir.
Thank you very much, sir, for your brief introduction about our first resource person, Dr. Deepak Kumar Rawal, sir. Rawal, sir, please.
Thank you very much, sir, for the very precise, very long introduction, rather. It was not brief, but it was very sweet. Everyone likes the praise, and those, I am thankful for those very sweet words. My topic of today's presentation is a green synthesis using ionic liquid as designer solvents. And along with me, Dr. Jamin Aulani has also helped me a lot in not only in the preparation of this manuscript, but also for doing some of the research work that has been incorporated in this talk. The main points that I have tried to cover in this talk are the environmental issues faced by the chemical industries, generated by the chemical industries and faced by us. Then, as I have been told that many of the participants are from undergraduate and PG classes, so I have also included 12 principles of green chemistry in this talk, as well as little bit introduction on the ionic liquid, and then I will go to the work that we have performed by using the green chemistry principles, and of course, everybody is waiting for the summary of the talk. Sir, am I audible?
Yes, sir.
Oh, I am audible. Okay.
Yes, yes, yes.
These are some of the well-publicized incidences from the past few decades. The first is this one, that Cuyahoga River in Ohio, that was so polluted that it caught fire. Only we have listened to the Hindi songs that "Pani mein aag laga dete hain," right? It's very unfortunate that actually in the river in the state of Ohio, Cuyahoga River, that water caught fire just because of very high level of volatile, those pollutants in the water. Then this is a very well-known incident that because of this methyl isocyanate that was released in Bhopal, 4,000 people lost their life. This is one more incident that occurred in Italy in the year 1976. I'm talking about all the developed countries. I'm not talking about our country, right? All this 1976, the accidental release of chemical that occurred in the river, and that I have tried to show it in this picture, that including dioxin, it was released in the river, and that resulted into the death of animals and long-term health problems for the local residents just because of the accidental release of the dioxin in the river. To overcome these difficulties, the international treaties have been signed, including the Montreal Protocol to protect the ozone layer, and then the Global Treaty on the organic pollutants, and then this Rio Declaration on environmental development. Somebody is trying to draw something on my presentation. I don't know why it is happening. I'm not doing this thing on my screen. This has been done by someone else. Okay. What is the cost to industry? That I'm talking about the states of America, United States of America, nearly $100 billion per year they have been used on waste disposal, waste control, and waste treatment. Right? These industry in United States are spending $100 billion, very large amount, behind the waste treatment and control. Of course, green chemistry is not about the treatment and control. Green chemistry gives us the idea about the prevention of the waste. So this much of the amount is spent just on the waste treatment and the control of the pollutants. Even DuPont that spends $1 billion for the environmental compliances. This business of chemical sales of $18 billion, DuPont is spending $1 billion behind the environmental compliances. So we must have to take the actions, and our chemical ecological footprint should be such that we should have to preserve our earth. Right? Our chemical pollutants should not cause damages to the environment just because of we want to sustain our environment, and the future generations should be protected from the dangerous those effects caused by the chemical pollutions. So green chemistry is all about preventing pollution for sustaining Earth. Green chemistry deals with the prevention of the pollution. Green chemistry does not tell us about the control and that measures those are involved in the control. But just for the prevention, we are going for the this green chemistry. Why do we need green chemistry? This slide gives us the idea about the requirement for the green chemistry. Why do we need it? Of course, chemistry is undeniably a part of our daily life. When we wake up in the morning, we have a toothbrush. We take toothpaste on it. So toothbrush is also a plastic product. Toothpaste is also a chemical product. And then when we go for taking a bath, shampoos, soaps, all those things are chemicals. When we wear clothes, clothes are also the chemical products. Clothes are colored, colors are also chemicals. So one cannot deny the prominent role of chemistry in our daily life. Chemistry is very much involved in our daily life. Chemical developments bring also the environmental problems. I request the participants to mute their mic. Participants are requested to mute their mics.
For 1 minute, please. 1 minute, please. Hello.
पाटील सर, विवेक पाटील सर, माइक म्यूट
पाटील
करा.
सर आपल्या कॅम्पस मध्ये कार्यक्रम चालू आहे, बंद करायला लावा सर त्यांना. आपल्या कॅम्पस मध्ये कार्यक्रम चालू आहे सर. हॅलो, त्यांना आवाज कमी करायला लावा, बंद करायला लावा. हॅलो सर, बहुत मोठा आवाज येतो, कार्यक्रम चालू आहे स्पीकरवर, तर बंद करायला लावा. हॅलो.
जाधव सर घेतोय नोटीस, त्याचं नोटिफिकेशन घेतोय.
हो हो हो.
बंद करा, बंद करा.
संविधान दिनानिमित्ताने आपण महामानव भारतरत्न डॉक्टर बाबासाहेब आंबेडकर यांच्या प्रतिमेचं पूजन करतो. संविधानाची जी उद्देशिका आहे तिचं वाचन.
हॅलो. ते बंद करायला लावा सर प्लीज, कार्यक्रम चालू आहे ना, तो बंद करायला लावा.
हो झाला, केला बंद केला.
ओके सर. Sir, please go ahead.
So we were over here that chemistry is a very prominent part in our daily life, and chemical developments bring about the environmental issues. The harmful, unexpected side effects are also associated, and that resulted into the need for greener chemical products. That's what the requirement of the era, right? We have this example of DDT. DDT was invented as a pesticide, but it has the harmful effect, and DDT is known to be a very powerful carcinogen. It produces cancer in human being. So this is the side effect that it controls the pest in the agriculture. DDT is very useful in controlling the pest, but the side effect is it is very potent carcinogen. It causes cancer in human being. So green chemistry looks at pollution prevention. What about the prevention is better than cure. Prevention, pollution prevention on the molecular scale. It is an extremely important area of chemistry due to the importance of chemistry in today's world. So this green chemistry program supports the invention of environmentally more friendly chemical processes. For what? We want to reduce or eliminate the generation of hazardous substances. Right? The pollution should be at the source. We should not have to go for controlling the side effects. but we should have to go for preventing the hazardous chemicals. So we should have to go for reducing or eliminating the production of hazardous substances. This program works closely on the 12 principles of green chemistry that will be discussed in the later slides. The 12 principles of green chemistry. This slide tells about the importance of green chemistry. It's all about reducing waste, right? We should not have to go for managing the waste, but the waste should be reduced at the source. Then the use of materials in the production of new products, use of materials in the formation of new products, that should also be reduced, because the lesser the amount, of course, all the resources on the earth are depleting, and we have to preserve the resources. Therefore, in the production of new product, we have to minimize the number of materials which we are using in the formation of new products. That material, use of material should also be reduced. Then the hazards associated with the chemical processes. Those hazards are also to be reduced by using the green chemistry principles, and the risk in working in the chemical industry should also be reduced. That is also one of the most important aspects of green chemistry. And the energy, right? The institutions are busy in developing the energy resources. We have the depleting energy resources. Therefore, in manufacturing processes, we should have to minimize the use of energy. And what is the meaning of reducing the energy use? We should be able to perform the reaction at lower temperature. Thereby, the energy will be saved. We should be capable of forming those products in less time. Thereby, the energy use will be reduced. And all these factors, when waste will be minimized, no expense is made after this handling of the waste, less material is used, the process is less hazardous, less risk is there, we are consuming less energy, then definitely that will be very cost effective. So finally, ultimately, the use of this green chemistry is to reduce the cost by saving energy, by reducing risk, by reducing hazards, by saving the material for the future generations, and by reducing waste level. This is a very well-known example for ibuprofen. I will start with this starting material, right? And then this is the final product. How many steps are involved in the formation of this product? Just look at this. Step number 1. This is step number 2. Step number 3, 4, 5, and 6. 6 steps are required for the formation of this important product, ibuprofen, from its starting material. We will go for the chemical reactions, which type of reactions we are performing in this process. The first step, what we are using is acetic anhydride and aluminum chloride. Acetic anhydride is a reagent and aluminum chloride is a catalyst, right? If you recall your chemistry, then this reaction is Friedel-Crafts acylation. This is Friedel-Crafts acylation. Look in the para position. In the para position, what is being substituted? COCH3, right? Acylation occurs in the para position of this alkyl group. So this is the Friedel-Crafts acylation reaction that we are also performing in our laboratory. Look at the red products. HCl is eliminated, acetic acid is eliminated, and aluminium is also eliminated as a waste. So what we are using in the first step, starting material, aluminum chloride and acetic anhydride. Out of this is completely used in the product formation. Aluminum and chlorine are totally lost, and they will create the hazard to the environment. The pollution will be caused by this aluminum and chlorine, and also half of the part of acetic anhydride is also generated as a waste, right? Those waste products I have mentioned in red color: HCl, acetic anhydride, acetic acid, and aluminum as a will be generated as a waste. So this first step is not a green step, because according to green chemistry, the atoms which are used in the process should be utilized at a maximum level. Instead of utilizing those atoms at a maximum level, we are losing this much of the products, this much of the byproducts, and that's a loss, right? This is formed. The first reaction is, we know, it's Friedel-Crafts acylation reaction. Now the second step is required. What is that second step? I am referring to the fundamental of chemistry useful for the PG and UG studies. Look at this. It's a ketone, and ketone is converted to this glycidic ester, right? What are the reagents? This is alpha chloro, this ethyl acetate, alpha chloro ethyl acetate, and we are using sodium ethoxide as a base. So sodium ethoxide will function as a base that will extract a proton from this methyl group. Alpha hydrogens are acidic, will be extracted by this base, and then that will make the attack on this carbon of alpha chloroethyl acetate. Chlorine will be replaced, and then I am not going into the detailed mechanism, but just to recall, this reaction is Darzan glycidic ester condensation. Ketone is converted into this glycidic ester, and the reaction is a very well-known name reaction. It is Darzan glycidic ester condensation. Upon hydrolysis, this epoxy ring will be hydrolyzed and a formyl function will be generated. So it's a ring extension reaction. This is a ring extension reaction, and the what happens in the first step? HCl is eliminated. At the same time, this acetic acid is eliminated. So this is also not an atom economic reaction. The byproducts are there, right? Chlorine is eliminated. Chlorine is disposed in the environment, and that will create pollution. HCl will create the pollution in the environment. So after this formylation, chain extension reaction, what we are going for is the oxime formation. Just the reaction of this carbonyl carbon with hydroxylamine, that gives the oxime, and that is reduced to nitrile, and that is hydrolyzed to the carbonyl. But look at this. At this, ammonia is liberated. That will create a problem to the environment. So the route is a classical route for ibuprofen preparation that involves 6 steps. Those steps are not atom economical. The meaning of atom economy is whatever we are using as a reagent, all of the atoms should be utilized for the product formation. That aspect of atom economy is not justified in this classical route of ibuprofen. Okay, then this is the green route of ibuprofen. 6 those steps were involved in that route, but now in this case only 1, 2, and 3 steps are there which convert the starting material to the product. First step is the acylation is performed in the presence of hydrochloric acid. Only acetic acid is eliminated. Just by doing this process catalytically by using HF, the aluminum waste has been eliminated. We have prevented the formation of aluminum waste by converting this process to the green route. Now this is reduced to the alcohol function, and then by using palladium metal as a catalyst, the carbonylation is performed to convert this group to the corresponding carboxylic acid group. This is the catalytic reaction, and the classical route uses 6 steps. The green route to ibuprofen has only 3 steps, and look at the number of waste that we have minimized. So this is a green route for the ibuprofen. Only 3 steps are there with the less number of side products with higher atom economy. You know the meaning of atom economy. Now we will quickly go for these 12 principles of green chemistry. Which are those? The first is prevention. And it is better to prevent waste rather than to treat or clean up waste after it has been created. It is said that prevention is better than cure. And that is also applied over here. That proverb is applied over here, that we should have to prevent the formation of the waste product after it has been created. It's better to prevent the formation before it has been created, right? So prevention is the first rule. You have to remember the 12 rules of green chemistry. Prevention is the first rule. Second is atom economy that I have described, that synthetic methods should be such that it should maximize the incorporation of all of the materials which we are using in the process, and that should be converted to the final product, right? All of the materials used in the preparation should be incorporated in the final product. That is about the rule number 2, that is atom economy. The chemical synthesis should be less hazardous. That's the third principle of green chemistry. Wherever practicable, of course, it's not practicable to each and every case. So wherever it is practicable, synthetic methods should be designed in such a way that it should generate the substances that has little or no toxicity to the environment. So we have to reduce the production and the use of the toxic material. That is the rule number 3. Then rule number 4 is about designing the safer chemicals. Chemical products should be designed to exhibit their desired functions while minimizing the toxicity. That is about the design of safer chemicals. Those should not be toxic to the people, toxic to the human being, and toxic to the environment and other creatures which are living with us. Number 4, that is the principle of designing safer chemicals which are less toxic. Then principle number 5 is for going for safer solvents and auxiliaries. That is the use of auxiliary substances that we are using in the chemical processes, the solvents, the catalysts, the separating agents. These auxiliary substances should be made unnecessary. Of course, not possible for all the processes, but in the cases where it is possible and innocuous when it is used, it should not harm us. This is the principle number 5, going for the search of safer solvents and auxiliaries, including the separating agents, the catalysts, and the solvents. This is number 6, a very important aspect in the days of energy crisis. Designed for this energy saving, right? Energy requirements of chemical processes should be recognized for their environmental and economic aspect. And the energy requirement should be minimized. We should be able to perform the reactions at room temperature, or the reaction should be performed by using those protocols. Of course, we are employing heat energy by the conventional method, the burner and the heat, but in the green methods, we have to go for ultrasonication, right? We have to go for microwave irradiations. So those are the non-conventional method of heating, and they are more energy saver. Energy can be saved by using ultrasonication in the chemical reaction. Energy can be saved by microwave irradiation rather than using the conventional method of heating. So actually, ideally, synthetic methods should be conducted at the ambient temperature and pressure. If the process requires high pressure, then also that will also consume the more energy, and that will be less economical to the industry. Number 7, principle number 7 is use of renewable feedstock. The feedstock should be renewable in the age of this depleting resources. Raw materials or feedstock should be renewable rather than this depleting source whenever it is technically and economically practicable. Once again, not possible for all the cases, but we should have to find out where the processes are technically practicable. economically practicable to justify the
साहेब काडा कोपऱ्याला तुमच्या नाही नाही गुलाबीच्या बागलाच आहे.
Number 8, to reduce derivatization. Of course, in the study of chemistry, you might have come across the blocking groups, protection and deprotection, and the temporary modification of physical and chemical processes. Those things we are performing in the laboratory. On the industry scale, also all these processes of derivatization are used. Those unnecessary derivatization which are not required should be minimized, and that those derivatization should be avoided if possible, because these steps, protection and deprotection, the temporary modification of physical and chemical processes will require additional reagents, and that will also generate waste. So our intention is to minimize the waste production, right? Our intention is to minimize the energy utilization. So we should have to stop this derivative accumulation. Because the chemical processes should be controlled. Chemical processes should be controlled. Catalytic reagents, they are superior to the stoichiometric reagents, and we should have to find out the catalytic processes for the important product formation. Design for degradation. Whatever we are producing should be decomposed. It should be degraded after its use, right? So less of the waste material will be produced, and that can be handled very easily. Therefore, we should have to design the product which is degradable after its use, and they should not persist in the environment. As we are facing a problem of plastic nowadays, plastics are non-degradable, and plastic is causing much of the problems to the environment. Then we should have to go for finding out the newer technologies, newer methods to design such a plastic material which can be decomposed, which can be degraded in the environment, and that can decrease the pollution level just created because of plastics. Of course, real-time analysis for the pollution prevention should be developed. Analytical methodologies are required that allow for real-time, that is monitoring, which is performed in process monitoring and control prior to the formation of hazardous substances. The hazardous substances, before they are formed, they should be controlled during the process by the real-time analysis method. That is principle number 11. And number 12 is the inherently safer chemistry for accident prevention. People are working in chemical industry. We are the student of chemistry. We have to work in industry, and the accidents in chemical industry will damage the human life. Accidents in laboratory, even in the college laboratory, if they occur, then they will damage us. Okay, accidents are accidents, and they are bound to give us the damage. So the safer chemistry should be developed for the prevention of accidents. This is principle number 12 of green chemistry. So just by having the quick look at the 12 principles of green chemistry, I am coming on a slide which tells us why we started our research in this direction. That is the driving force for designing our research. What is it? We are in search of greener processes. We know the importance of greener processes to reduce the materials used for the product formation, to reduce the energy, to reduce the risk, to reduce the cost, to minimize the use of chemicals, to minimize those high temperature and high pressure, those reaction processes. The conditions should be such that the reaction should be performed at ambient temperature and normal pressure. Okay, so those greener processes are required, and we are in search of the greener processes that can less damage the environment, we tried our research, and the catalytic reactions are required in the green chemistry. They should be recycled. The meaning of recycling is once the catalyst is used in a reaction, that should be employed once again in the another cycle for forming another batch of the product. And then for the third batch and for the fourth batch, the recycling capability of a catalyst should be checked for the greener aspect. And also the solvents should be recycled. That was the driving force for designing the research in my lab. Okay, we concentrated on ionic liquids. They are used for clean processes and green chemistry, green processes, clean and green. Why? Because these two catchwords, clean process and green process, they mean to drastically reduce the amount of side and coupling products and the amount of solvent that we are using in the process and the catalyst we are using in the chemical process. Clean process and green process means we are reducing the production of side product and the coupling product, and along with it, we are also reducing the use of solvent consumption and catalyst consumption. Okay, why to consider the ionic liquids? They are environmentally friendly, right? And they are the alternatives to the organic solvents. Where they are used for liquid extractions. They are used, these ionic liquids are used for catalysis. Ionic liquids are used for separations, and ionic liquids are also used for electrochemistry. So these are the fields where ionic liquids are employed, and they are more environmental friendly than the organic solvents. These ionic liquids will reduce or eliminate completely the cost of the material, the disposal requirement, and the hazards associated with VOCs. VOCs are volatile organic compounds. So they are very hazardous. By using this ionic liquid, we can eliminate the hazards caused by VOCs, the volatile organic compounds. Ability to fine-tune the properties of the ionic liquid will allow selection of ionic liquid to replace specific solvent in a variety of different processes. This is very important. We can design the ionic liquid of our interest, of our application, and that is the meaning of this fine-tuning, right? You are fine-tuning your television sets, and here this research we have attempted to fine-tune the property of ionic liquid by modifying the structure of ionic liquid. So those ionic liquids are very good in these chemical processes because their properties can be fine-tuned. Therefore, I have given a complete site to a single sentence. Their properties can be fine-tuned just by the changing in their structures. This is a bottle that shows the ionic liquid prepared in my lab. Yes, this is the definition where what are the ionic liquids is the generic term for a class of materials consisting entirely of ions and being liquid below 100 degrees Celsius. These are the ionic liquids, right? Of course, the melting point is below 100 degree. Therefore, they are liquid at room temperature. And those room temperature liquids are known as RTIL, that is room temperature ionic liquids. This diagram shows the picture for the sodium chloride, where you can find that the anions, chloride ions and sodium ions, they are symmetrically arranged, right, in the cube. So anions are symmetric, also the cations are symmetric, but this is the difference in the ionic liquid. What is the difference? These are the anions, right? But look at the cations. Cations are not symmetric, they are asymmetric. So cations are asymmetric in the ionic liquids. They cannot be arranged in a particular fashion just because of the asymmetry involved in the ionic liquid case. This is symmetric and they can be packed. But these are liquid at room temperature. These are the typical examples for ionic liquid. Typical cations are pyridinium ion. This is pyridinium ion, and imidazolium ions. They are the typical cations used for the preparation of ionic liquid, right? So many different anions can be used, and by changing either the cations or the anions, we can have the desired properties. The properties that we want to generate in the particular liquid can be designed, can be achieved by changing the cations and anions. Okay, so these are the different anions that I have listed. For moisture stable and water immiscible ionic liquid, if we want to form this type of the ionic liquid, which is water impossible and water immiscible, then we have to go for this anion. The moisture stable and water miscible ionic liquid, I think you are getting my point, right? Just change the anion. When you are using PF6, then the ionic liquid is water immiscible. When you are going for this tetrafluoroborate, PF4, then it is water miscible. The property can be fine-tuned according to our wish, according to our need, according to our desire. The property can be fine-tuned, and then, of course, this AlCl4, when this is used, this is employed as an anion, then it decomposes in water. So just by changing the pair of cation and anion, we can have the ionic liquid of our choice. Once again, a list of cation and anion is given over here. Ammonium salts, phosphonium salts, imidazolium, pyridinium, these are the cations, and all these are different anions. The combination of these will prepare a large number of this ionic liquid for us. This is about the history. In 1914, ethyl ammonium nitrate was discovered by Paul Walden as the first ionic liquid, which was low melting point salt, right? And then in 51, another liquid was invented. That was N-ethyl pyridinium bromide aluminum chloride. That was first room temperature ionic liquid that was invented in 51. And then in 82, this dialkyl imidazolium salt were invented. They are the stable and conductive salts useful for the electrochemistry. They were invented in 1982. And then hydrophobic ionic liquids were invented in 1992. And this is the example: ethyl, methyl, imidazolium, tetrafluoroborate. So this is about the history. We are going to the use. What are the advantages of ionic liquid? Yes, their separation is easy. They have very low vapor pressure. They have non-flammable flammability. They are non-flammable. Other organic solvents, I am talking about the volatile organic compounds, right? They are inflammable. And these liquids, ionic liquids, are non-flammable. They are thermally very stable. They have high thermal stability. They have high mechanical property, mixed stability. Electrochemically, they are also stable. Ionic liquids have very low toxicity and they are non-volatile. So these are the advantages of using ionic liquids in the synthesis. Once again, a table there that shows the superiority of ionic liquids over these organic solvents. Organic solvents are more than 1,000, and ionic liquids have to contact Mr. Amitabh Bachchan in Kaun Banega Crorepati to count down the number of zeros. 1, 2, 3, 4, 5, 6, 10 lakh, right? So this is the number of ionic liquids that is obtainable by having that match between the different cations and anions. Of course, it's multifunctional. Those lists I have shown to you to show their applicability. Then they are catalytically applicable, and the catalytic activity is tunable. Then, of course, these solvents are catalytically not used. Chirality is also tunable. Vapor pressure is very negligible. All those points are very useful for as far as the ionic liquid is concerned, except this, except this, cost. Organic solvents are normally cheap, easily available, whereas ionic liquids are typically between 2 to 100 times higher in cost than the organic solvents. They are not cheap, right? We have to pay more for the ionic liquids, and we have to go for reducing the cost over here for the ionic liquids to make the maximum use of the ionic liquids. Otherwise, if you look at the other properties, ionic liquids are superior to organic solvents, except the cost. Why money matter karta hai na? It's money matters. So it's not cheaper. These solvents are cheaper. Listed the organic synthesis in which ionic liquids are used, and this is from the literature. They have various catalytic applications in hydrogenation, hydroformylation, in Heck reaction, in Suzuki coupling, Stille coupling, Friedel-Crafts reaction, carbonylation reaction, this olefinic dimerization, Diels-Alder reaction, oxidation. In all these reactions, ionic liquids have been employed and already reported in the literature. So just by getting motivated from the literature survey, we started our work. Of course, this is beginnerly like synthesis, where we try to prepare pyrazolo 3,4-D pyrimidine. It's a heterocyclic compound, and heterocyclic compounds are very useful for their pharmaceutical applications. So most of the organic chemists, they are busy in doing the research and finding out the greener routes, the shorter routes, the environmentally safe routes for the preparation of heterocyclic compounds because of their applicability in the pharmaceutical field. We are also trying to have this pyrazolo pyrimidine by using this beginnerly synthesis under sonication. So it's a non-conventional method. We have not used burner, but under the sonication, we have attempted this synthesis in the presence of this Bronsted acidic ionic liquid, and also have discussed its mechanism. This paper is published in Journal of Heterocyclic Chemistry. What I want to show is to my young friends, to my friends who are in the MSc class, that by using very simple chemistry, you can have a very good publication. You can go for very good research just by having this simple chemistry. I want to highlight on the fact that you don't have to go for very hi-fi chemistry for doing research, for contributing in the field of research. Just go for simple chemistry and you will be able to do it. You will be able to have very good papers. You will have good credit just by using the simple concepts of chemistry, and those concepts now I am trying to show in this presentation. Look at the components: aldehyde, RCHO, right? This one is also urea. You can also take thiourea just by replacing X by S. If X is O, then it's urea. Have a variety of those substitutions in this one. So urea can be urea or thiourea. And the third component is pyrazolone, is pyrazolone derivative. Particularly this is 3-methyl, 1-phenyl, 5-pyrazolone. This is the pyrazolone. This reaction is performed in a single step. This is known as multi-component reaction. It's a multi-component reaction. 1, 2, and 3 components are used. This reaction was performed in the presence of butyl imidazolium tetrafluoroborate. This is the abbreviation for that ionic liquid. Butyl imidazolium tetrafluoroborate. And this sign shows that the reaction was performed under sonication. It was not heated by using the electrical devices or by a burner, but this reaction was performed in the presence of waves, sound waves, ultrasonication, right? Just look at the product. Just look at the product. This is our pyrazolone derivative. and pyrrolizolone derivative, a new ring is formed. A new ring is formed between these two carbons. Just simple, very simple. A new ring is formed between this carbon and the carbonyl carbon of the pyrrolizolone. Just look at this. A new ring is formed, and it's a pyrimidine derivative, right? Pyrrolizolone and pyrimidine, they are fused. So it's a pyrrolizolopyrimidine derivative. This is pyrrolizolopyrimidine. I'm not going into the detailed IUPAC nomenclature, but pyrimidine and pyrrolizole, they are fused together. Therefore, this is the pyrrolizolopyrimidine derivative. That's all up to this presentation. Okay. This is about the mechanism of the reaction. Organic chemists should be capable of explaining the steps involved in the reaction that he is performing, right? And I have tried to explain the reaction mechanism. This is the ionic liquid which has a hydrogen attached to the nitrogen, right? It's the IL, that stands for the imidazole ring, and the liquid is butyl imidazolium tetrafluoroborate. So this hydrogen is attached to nitrogen in the catalyst, and the hydrogen attached to electronegative atom is capable of doing this. That is shown by the dotted line with the oxygen. What is it? That will form a hydrogen bond, right? So that hydrogen bond is formed by the hydrogen available with the ionic liquid with the carbonyl oxygen of pyrrolizolone derivative. This one. What is the purpose of forming that hydrogen bond? By engaging the electrons of this oxygen with the hydrogen in the formation of this hydrogen bond, carbonyl carbon. This carbonyl carbon is activated, becomes more electrophilic, right? And these hydrogens will come to this oxygen, as I have shown by putting this hydrogen over here. From where this hydrogen has come? Look at the sign, this one, the arrows. That shows that these two are tautomers. This is the keto form and this is the enol form. So it's a keto-enol tautomerism that has been initiated by the hydrogen bond formed by the catalyst of this catalyst ionic liquid, and the enol form is generated. In the enol form, this particular carbon is nucleophilic by utilizing the electron supply available from this OH bond. Look at the arrow. Arrow in the organic chemistry shows the movement of electrons. Electrons are shifting between these two atoms, carbon and oxygen, and these electrons are making the nucleophilic attack on an electrophilic carbon. What is this? This is the aldehyde that we have used in a multi-component reaction. Aldehydic oxygen is also forming hydrogen bond. Electrons are engaged in the formation of this hydrogen bond. Therefore, this carbonyl carbon becomes more electrophilic in nature, and it is being nucleophilically attacked by this carbon to give this product. And once again, I would like to recall that this is nothing but a Knoevenagel condensation. Right? Simple chemistry of FY and SY BSc class we are using for the research. This is nothing but the Knoevenagel condensation. And then what is formed is alpha. This is a carbonyl. This is a carbonyl function. Alpha beta unsaturated carbonyl derivative is generated, and this is undergoing the nucleophilic attack by the electrons available with the nitrogen. This is a lone pair. This is the lone pair of electron, right? And that makes the nucleophilic attack on this beta carbon of alpha beta unsaturated carbonyl cysteine, and that attack ends over here to give this as the intermediate. And this is, of course, the nucleophilic attack occurs on the alpha beta unsaturated carbonyl. This is known as Michael addition, right? Nucleophilic attack on this is Michael. This is Knoevenagel, this is Michael, and gives this intermediate. Now, carbonyl carbon is electrophilic. In the vicinity of the carbonyl carbon, there is nitrogen with the lone pair. It's nucleophilic. Makes the nucleophilic attack on the carbonyl carbon, and this ionic liquid is relieved from the molecule that results into cyclization to give this. Ionic liquid is relieved just by forming a bond between this nitrogen and carbonyl carbon. Nitrogen and carbonyl carbon. Double bond O is converted into OH. Look at the arrows now. Alpha and beta. Hydrogen is lost from this. Electrons are used to put a double bond between these two carbon atoms. Hydroxyl is relieved. H and OH, they are eliminated from the molecule, and this is beta elimination. By beta elimination, water molecule is lost to give the product, and 6 A to I products were generated depending upon the variations in this R group. Different aldehydes were taken, and these products were formed. Okay, so I have tried to explain you the mechanism, the role of ionic liquid, that is in the hydrogen bonding, that makes the enol form. Here with the aldehyde, the hydrogen bond that activates the carbonyl carbon, makes it more electrophilic. No energy condensation, Michael addition, cyclization, and beta elimination gave us the product. This is another paper published in this journal. It is by the Elsewhere, and once again, it's a multi-component reaction. It's a multi-component reaction, and 2 moles of diamidone were used. Diamidone and dimidone, aldehydes, different aldehydes were used, and by using this 3 components, I've got 2 components. This is the reaction which is performed at room temperature under sonication. Under the effect of sound waves, this was performed. And this is carboxymethyl methyl imidazolium tetrafluoroborate. The cationic part is modified. Cationic part is modified. I will show you the structure in the next slide. It is carboxymethyl. One group is carboxymethyl, another is methyl on the imidazolium ring, right? So the cation is modified just for having the different type of properties, and the reaction was performed at room temperature just to eliminate just to reduce the energy and to make the process cost effective. What happens? Once again, a new ring is formed, right? Between these two, a new ring is formed, and this is the R that has been found to be incorporated over here, right? So a 3-member ring is formed out of this starting material. We have formed this xanthine derivative. Dioxoxanthine is formed, and by performing the reaction at room temperature under sonication in the presence of ionic liquid, carboxymethyl methyl imidazolium, this was attempted and published in a very good journal Elsewhere. Once again, I have tried to show that. Look at this. Methyl. This is carboxymethyl imidazolium ion, right? Methyl, and this is carboxymethyl. Carboxymethyl methyl imidazolium ion. This is the hydrogen available with the ionic liquid, the catalyst, that forms a hydrogen bond with the carbonyl oxygen, and thereby the enolization occurs. Carbon is becoming more nucleophilic. Electrons are utilized over here. Have to see in the direction of arrows. The arrow shows the movement of electrons. These electrons are now making nucleophilic attack onto the carbonyl carbon. This aldehyde is also activated just because of the same thing over here. Hydrogen bond is formed between the catalyst and the carbonyl oxygen. Electrons are used, they are engaged in the formation of this hydrogen bond. Therefore, carbonyl carbon becomes more electrophilic, undergoes the nucleophilic attack. Then those steps are common: no energy condensation and Michael addition. That gives us this uncyclized intermediate. This was isolated. This intermediate was isolated in the reaction, and then that was cyclized to remove the water molecule to give this xanthine derivative. This dioxo-octahydroxanthine was produced just by eliminating water molecule. The structure of this intermediate is very interesting. Why? Usually in the chemistry classes, we learn that keto forms are more stable than enol. Look at this. In the molecule, these are the 2 enols, right? 2 enols are there. Instead of course, when this hydrogen will migrate from oxygen to carbon, you are getting my point. When this hydrogen is undergoing the migration from oxygen to carbon, keto form will be generated. On the other side also, when hydrogen migrates from oxygen to this carbon, the keto form will be generated. So it will be a diketo form, right? But we also have checked this structure and have confirmed that this is occurring in its enol form by looking at the NMR of this particular material, this carbon, right? This carbon has one or the different substituents according to the according to scheme, whatever the R is taken over here. But we are interested in this methane carbon. This has one hydrogen, and look at this. That there are no those protons adjacent to this methane carbon. Therefore, the shift due to this methane will be a sharp singlet, right? And we obtained that sharp singlet in the NMR to prove the structure of this uncyclized intermediate in its enol form. Unfortunately, our observation is not matching to the standard that stability of the enol and keto form. Keto forms are generally believed to be more stable than the enol, but we have isolated this structure. We have also recorded the NMR, and I will show that NMR where this methane proton is migrating as a sharp single signal. Okay. Of course, to investigate the role of ultrasound, the reaction was carried out under simple stirring at room temperature. Formation of the product was not observed. Therefore, we proved that ultrasonication is required, and the reaction is not possible even after 3 hours of the reaction. Even after 180 minutes of the reaction, we continuously stirred the reaction mass. Nothing was obtained in the absence of ultrasound. So ultrasound played a very important role in completing the reaction. This is about that talk that I have given, that the keto and enol form. The hydrogen on methylene breath, that is methane hydrogen, is observed as a singlet, right? Instead of coupling over there, it is observed as singlet. That proves the enol form. This is that NMR where that signal is observed over here, right? Sharp at 5.5, the methane signal was observed, and that proves the structure for the intermediate. Recyclability of ionic liquid. Once again, the principle of green chemistry. For the first cycle, the catalyst was found to be, catalyst is ionic liquid, was found to be effective up to 87%. And then after the 6th cycle, that was found to be 84% effective in performing the reaction. So no that remarkable loss is observed in the catalytic activity of the reaction. So what my intention is just to show that by using simple chemistry, we are able to do very good research in our laboratory, in normal laboratories which don't have any financial stability, the financial strength. Okay, we can go for very good chemistry by using simple chemistry, simple reactions, simple reagents. This is the third paper in which this ethyl acetoacetate and ammonium acetate and aldehydes are used. This R and R1 may be changed according to the research plan. This reaction is performed in the presence of methyl imidazolium tetrafluoroacetate. That's what the name over here. On methyl imidazolium, trifluoroacetate. There are 3 fluorine atoms. Trifluoroacetate, and that has been abbreviated as HMIMTFA. That is methyl imidazolium trifluoroacetate. This is the ionic liquid. Under the microwave irradiation, this reaction was performed. This is also the case of cyclization that I have tried to show it over here. These 2 molecules, the third one, aldehyde and ammonium acetate, get cyclized to give us this product, right? And this is the simple dihydropyridine derivative, and the scheme is shown over here. Of course, this one, the hydrogen attached to nitrogen of the ionic liquid forms the H bond, activates the carbonyl carbon, and everything that occurs in the reaction mechanism that we have already seen in the earlier cases. So I am not going to describe that those steps once again in this scheme. This is published in RSC Advances. What is it? What is the target? We have gone for the preparation of tri-substituted pyridines. This one, tri-substituted pyridine. Pyridine derivative is tri-substituted, right? And the catalyst that was used is acidic ionic liquid that was immobilized on cellulose, right? And that was found to be an efficient and recyclable heterogeneous catalyst. Catalysts are of two types, homogeneous and heterogeneous. This is efficient and recyclable heterogeneous catalyst for solvent-free green chemistry. Solvent, the use of solvent should be minimized. Solvent-free synthesis of this product. Okay, the reaction is simple. The aldehyde is taken, ketone, then an ammonium acetate. This was prepared in the laboratory. Reaction was performed at comparatively lower temperature, just 110 degrees Celsius, solvent free. No solvent is used in this reaction. No solvent is used. Nothing is used. This is the scheme. This is trimethoxysilyl ethyl chloride. 1 and 2 carbons are there. Trimethoxysilyl ethyl chloride that was reacted with this butyl imidazole. This is 1, 2, 3, and 4. Butyl imidazole. The nitrogen is nucleophilic. This carbon is electrophilic. Nitrogen makes the nucleophilic attack on the carbon. Chloride departs in a standard nucleophilic substitution reaction. So this is that nucleophilic substitution that was performed at 120 degrees Celsius. This was performed a nucleophilic substitution. What happens? Chlorine is replaced by this imidazole ring, right? Simple nucleophilic substitution. Then the counter anion was chloride that was replaced by this HSO4 minus just by mixing sulfuric acid with this IL-1 at 50 degrees Celsius for 8 hours. These two were mixed just to exchange the anion. And then this soda cellulose, this was treated with soda cellulose to immobilize this molecule was formed, and this has been immobilized onto this cellulosic moiety. CEL means CELL means cellulose. So this moiety is immobilized on cellulose to prepare our catalyst. So this is about the preparation of the catalyst, and that is obtained in the powder form, and that was used for the synthesis of tri-substituted pyridines. This is one more protocol for the synthesis of this pyrimidinone, this pyrimidinone derivatives, right? You can have different types of substituents over here depending upon this urea or thiourea. X may be oxygen, X may be S, and depending upon that, you have different varieties. Of course, it's a multi-component reaction. Aldehyde, ethyl acetoacetate, and urea and thiourea were employed. I am interested in this thing. Reaction is performed at 30 degrees Celsius. Reaction was performed under ultrasonication, so by non-conventional method, and just finished in 30 to 70 minutes. I was able to perform this reaction within 30 to 70 minutes. Of course, I am using myself, but my students have worked for this. I was only a person sitting in the chair and directing them to work for this. Very hard work is required. Of course, we have used simple chemicals, simple chemistry, but very hard work is required to put the work on the international level. This is the mechanism that I have already discussed, right? Hydrogen bonding is important, and then that activates this. This makes the nucleophilic attack, and the reaction goes on. We will not go into the detail because we have already seen those points in detail. But yes, this was asked by the referee that you are claiming that hydrogen bonds are formed, and that we have shown in the literature, in the scheme, this by this dotted line, that this ionic liquid is forming a hydrogen bond with the carbonyl oxygen of aldehyde, right? This hydrogen of the ionic liquid is forming hydrogen bond with this ethyl acetoacetate. Then the referee asked me to prove the presence of hydrogen bonding in the mechanism. And that consumed for almost a month for us. What we did is once again a very simple thing, very simple. We take this para-tolualdehyde, right? Is an aldehyde. The carbon 13 NMR was taken, and this carbonyl carbon was found to be resonating at 190, right? The range for carbonyl carbon in carbon 13 is 190 ppm. That was observed. Then this para-tolualdehyde was mixed with carboxymethyl methyl imidazolium tetrafluoroborate. Those two were mixed, and the CMR was once again recorded. Just 0.2 ppm shift was observed. 190.6 was observed to be at 190.8. So the signal slightly shifted in the upfield region. Then we went for this one. Mixture of this ionic liquid was taken. Mixture of ionic liquid. This is carboxymethyl methyl imidazolium and butyl methyl imidazolium tetrafluoroborate. These were mixed, and the carbon 13 NMR was recorded, and we found that the signal due to carbonyl carbon was shifted to 196. That shows that, that proves that actually the oxygen is engaged in the formation of a hydrogen bond just because of the shift observed in the upfield direction, right? The same thing was found true for this ethyl acetoacetate. Ethyl acetoacetate alone shows as signal at 200.4, and in the mixture, the signal is found to be shifted to 205.1 in the upfield region. That proves the presence of hydrogen bond when these are mixed. In the presence of a single ionic liquid, maybe because of the solvation, less solvation, the less degree of hydrogen bonding is occurring. But in the mixture, to the prominent extent, hydrogen bonding is found. Look at this, 190 is shifting to 196. 200 for this is shifting to 205. So thereby, we have succeeded in proving the presence of hydrogen bond between these two, and the publication was accepted. This thing I already discussed there, and a shift of 5 ppm is observed due to the interaction with the ionic liquid that we have discussed. Okay, so finally we have come to the conclusion. Which are the green aspects I have used in my research? Yield of this ionic liquid was found to be as high as 99%. It means I have followed principle number 2, maximum atom utilization. Whatever we are using in the reaction, they must be reflected in the product formation. So the yield of ionic liquid is of course 99%. So maximum atom utilization. Thereby, I have followed the principle number 2 of green chemistry. Separation of ionic liquid was easy just by the filtration, so it's energy saving. Reaction conditions were mild. You have seen that the reactions were performed at room temperature, right? So principle number 12 is followed. Very less byproducts are formed. In certain cases, byproducts are not at all formed. No byproducts are formed. So principle number 8 is followed in my research. Ionic liquids, they also acted as solvents in this reaction. Thereby, we have minimized the waste. We have prevented the use of solvent. That is the principle number 1. Prevention is better than cure. And then ionic liquid can be used directly for the next term that I have shown by that study of the recyclability. That is principle number 7 that is followed. Reactions were performed under mild conditions, and that required less time, thereby save the energy. They are energy saving. Principle number 6 of the green chemistry. And this is the conclusion what I have talked today. I'm not reading those things once again, but I think I have conveyed my message to the young friends that you can use simple chemicals, simple chemistry to have good publication, good credentials to you, but you have to put very hard efforts in the laboratory to put some good work. Okay, I wish you all the best. These are the list of publications, and yes, this is me. Right? You have already listened that I am a member of BAPS. BAPS is a Swaminarayan Sanstha, Kochasan Vasi Sri Akshar Purushottam Sanstha, and the red mark is over here on my forehead. I am always putting this on my head to just to show that I am a devotee of Lord, right? And this is the symbol for Ma Lakshmi. She stays on my forehead. This is me, and for today's presentation, everything, the slides were prepared by this gentleman, Mr. Jimmy Navlani. He prepared all these slides.
थोडे तास 3-1 तास मीनाबाईकडे गेलो आदल्या दिवशी तिने काय जाऊ दिलं नाही.
And these are the friends who work
दुसऱ्या दिवशी ताईकडे गेलो इथे पण भाऊबीज असते इकडे.
who work very hard to put this work and make me represent work on a national level. So I am also thankful to them.
याला महापालिकेमध्ये जाते कोविडची चीफ होती चौथा महिना.
Please wake up. Please wake up.
ऍडमिनिस्ट्रेटर
About this thing.
पेशंटशी काही संबंध नाही.
I am too much worried about
कोणी
them.
जर आजारी पडलं त्याच्यासाठी
We have to
बेड
say
उपलब्ध करून देणं, ऑक्सिजन उपलब्ध करून देणं,
somebody has turned on.
लागेल त्याला
Please
उपलब्ध करून देणं म्हणजे हॉस्पिटलला देत देणं.
turn off your microphone.
जास्त बिल लावलं काय केलं तिला कंप्लेंट दिली तर ती रिझॉल्व.
Kailas, Mr. Kailas, please switch off your microphone, please. Mr. Kailas. This is a call. We have to wake up. We have to wake up to make our world sustainable. We are very much worried about the forthcoming generations. And thank you all for the listeners' patience.
Hello.
I am also thankful to this college for inviting me to deliver the talk and to give me a chance to present my work and to motivate the students who are very eager to pursue their career in the research. Thank you once again. Thank you all.
Thank you, sir. You were listening to Dr. Deepak Kumar Rawal from Sardar Vallabhbhai Patel University, Anand, Gujarat. During his lecture, he came across the green chemistry concept, which were unknown to us. Now, if there is any question, they may ask them. Is there any question? Hello, is there any question?
Sir, Professor Jadhav?
Yes, sir.
May I ask one question?
Yes, you may go ahead, please.
Sir, regarding hello, sir.
Yes,
Hello.
you are audible to me. You are audible to me.
Yes, sir. Your presentation is very nice. I asked one question regarding green chemistry and your environmental chemistry. Hello.
Okay, sir. Haji, yes, you are audible to me, sir.
Yes, sir. Is there a similarity between green chemistry and environmental chemistry?
Green and?
Is there any similarity between green chemistry and your environmental chemistry?
Inorganic chemistry.
Environmental, sir.
Environmental chemistry.
No, sir. No. They are totally different.
Okay.
Different fields. Environmental chemistry and green chemistry. Because environmental chemistry deals with the analysis word, right? In which we have to go for finding out the solutions to the problems. And green chemistry is specially meant for preventing those problems at their source. That is about the green chemistry. Okay.
Hello.
Okay. Thank you much.
Hello. Any questions? I think there is no question from participants, sir.
I once again thank all the participants and the college for giving me this chance. Thank you.
Thank you, sir. You have given a lecture on green chemistry, very lucid language. Thank you, sir.
Thank you very much.
Okay, sir. Now, I'll turn towards the next quadrant of this webinar. I request our IQAC chairman, Mr. Ajay Tribhuvan, to give his preface about IQAC in brief. Yes, sir.
Okay, good afternoon, everyone. Honorable all the dignitaries, resource persons, and the participants. First, I welcome all of you. It's my prime duty as a IQAC coordinator. Quality assurance and the enhancement is a continuous process for which the internal quality assurance cell, that is the IQAC, has been constituted in Swami Muktananda College of Science, Yeola, in the year 2005. Since then, IQAC has evolved the mechanisms and the procedures for the predefined objectives by the formation of different committees. IQAC functions as an advisory body to the college on academic and the research activities, infrastructure development, students' welfare schemes, and the extension activities. It facilitates various activities for the overall development of the college in the consonance with the challenges of higher education at the local, national, and the global levels. IQAC is made effective, which may serve as a powerful tool for efficient administrations in the institutions. Arranging the conferences, seminars, webinars is the part of research activity which runs through IQAC. Conferences, webinars are the platforms for the sharing the knowledge, ideas from the expert to the society, stakeholders. Today, our
त्यांची रेंज गेली वाटतं.
chemistry, which is the applies on the 12 principles. He explained in his very nice lectures. Green chemistry, also known as the sustainable chemistry. Why the need of the applying the green chemistry? Because we are use the number of toxic substances in different field only for the better things for the human sake, or the better productivity for the human sake. But other side of this, the undegradable chemicals produce the pollution which the directly affect on human beings and the animal and the plant life. Green chemistry is based on the total 12 principles. These are enclosed in a single word, that is the productively. Each alphabet of this word has one principle. P stands for the prevent wastes. R for renewable material. O for omit derivatization steps. D for degenerate chemical products. U for use of safe synthetic methods and use of natural environmental energy resources. C for catalytic reagents. V for the very few auxiliary substances. T for the temperature, pressure, ambient. I for the in-process monitoring. V for the very few auxiliary substances. And the E for the E factor maximize feed in the product. L for the low toxicity of chemical products. And the Y for the yes, it is a safe. Green chemistry, it is a very, very safe. So today, whatever the first resource persons, they are delivered the very, very nice and the knowledgeable lecture on the green chemistry. And I hope that whatever the well-known personality, another resource person, Dr. V.B. Gaikwad, everybody known them. They also have the well experience and the direct field knowledge in at the green chemistry.
Stop
They
screen
also
sharing now.
give the
Organize.
fruitful lecture to us. Thanks to everyone. Take care. Stay home. Stay safety. Stay healthy. Thanks.
Thank you very much, sir, for your brief information regarding IKC and its role in our college development. Now turn towards next quadrant, that is second session. And second session, we have with us Dr. V.B. Gaikwad, sir, Principal, KTHM College, Nasik. He is going to talk on green and clean chemistry. Before going in, I invite my colleague Raghunathji Sonone to give his introduction. Sonone, sir, please.
Hello, sir. Am I audible? Hello, sir.
Yes, you are audible, sir.
Okay. Thank you, sir. Good afternoon to one and all. It's my pleasure to introduce our eminent resource person, Honorable Dr. V.B. Gaikwad, sir, for second session of National Webinar on Green and Clean Chemistry. Sir is principal of KTHM College, Nasik. College is NAC re-accredited in third cycle with A++ grade with CGPA of 3.79, which was highest in Maharashtra in September 2017. Sir is member, Senate and Management Council. Sir is former BCOD Director of Savitribai Phule Pune University, Pune. Area of specialization is material chemistry, gas sensing, environmental chemistry, green chemistry, nanotechnology, instrumentation. Research profile, Google Scholar citations are 1,748, H index are 20, I10 index are 37. Sir is recognized research guide of Savitribai Phule Pune University, Pune since 2003. 16 students completed their PhD degree under the guidance of Sir as a guide. 10 students completed their PhD degree under the guidance of Sir as a co-guide. 5 students completed their MPhil degree. Presently, 2 students for PhD and 1 student for MPhil are working under the guidance of Sir. Number of books authored by Sir are 17. Research paper. Sir has published 80 research papers at international level, 12 research papers at national level. The number of book chapters are 30. Resource person. Sir worked as a resource person in 19 international conferences, in 28 national conferences, and in 30 UGC sponsored refresher courses. Current academic position, Sir is a member, Senate and Management Council, Savitribai Phule Pune University, Pune, member, College with Potentials for Excellence, UGC, New Delhi. Sir is assessor of NAC peer team, Bangalore. Sir is member of Research and Recognition Committee, Gondwana University, Gadchiroli. Teaching, administrative and research experience is 39 years. Sir started his career as a lecturer in 1981. Sir became principal in 1996 and presently Sir is principal of KTHM College, Nasik. Awards, honors and prizes. Sir received Best Teacher Award by Government of Maharashtra in 2011, E-Governance Award by Government of Maharashtra for automation of various processes of admission, affiliation, examination, migration in 2013. Sir received Best Principal Award by University of Pune in 2007, Best Principal of the Year by Australian Chemical Society in 2006, Best Chemistry Teacher Award at national level organized by Tata Chemical NCL CSIR on International Chemistry Year 2011. Academic and administrative positions held at UGC, university and college level. Sir is former BCUD Director of Savitribai Phule Pune University, Pune, 2012 to 2017. Member, Management Council, SPPU Pune. Dean, Faculty of Science, SPPU Pune. Member, Senate, SPPU Pune. Member, Academic Council, SPPU Pune. Controller of Examination, SPPU Pune. Member, Advisory Committee, Academic Staff College, Savitribai Phule Pune University, Pune. Chairman, Board of Studies and University Development Subcommittee, Savitribai Phule Pune University. Director, Universities, Nasik Subcenter, Savitribai Phule Pune University, Pune. Presently, Sir is President of Hydrological Data Users Group, Maharashtra State. Chairman, Research and Recognition Committee, Yashwantrao Chauhan, Maharashtra Open University in 2005-2007. Member, Board of Examination, SPPU Pune. Member, Board of Studies, Chemistry, Savitribai Phule Pune University, Pune. Member, Colleges with Potential for Excellence, New Delhi. Member, Faculty of Science, North Maharashtra University, Jalgaon. Member, Advisory Committee of Baba Atomic Research Center, member. Role on different advisory bodies. Sir is member of Governing Body of VIT College of Engineering, Pune. Governing Body of Cummins College of Engineering for Women, Pune. Governing Body of MIT College of Engineering, Alandi. Governing Body of Guru Govind College of Engineering, Nasik. Overall impact as BCUD Director in Savitribai Phule Pune University, Pune. Sir play a major role in A+ NAC accreditation of the university. Effective role in securing 10th position of university in NIRF ranking framework. Contribution in availing UGC, DST, DBT, SAP, CAS grants from various apex bodies of MHRD. Coordinated and utilized grants of different schemes with effective planning. Initiatives for establishment of in-house IT cell. Active role in implementation of choice-based credit system for PG level and UG level. Active role for establishing skill development center at SPPU University campus. Sir guided for signing of MOUs with 19 foreign universities, 26 Indian universities and institutions for joint research project, student exchange, faculty exchange, teacher training program. Sir is coordinator for Avishkar Research Project competition of Savitribai Phule Pune University and own state level general championships for 4 times. Encourage college and university teachers to avail BCUD research project schemes. Successful implementation of Quality Improvement Program Scheme, initiative to start skill-based BHOG programs at university campus. Overall impact in capacity of principal at KTHM College, Nasik. Under the guidance of Sir, KTHM College achieve A++ level in NAC re-accreditation at 3rd cycle with CGPA of 3.79 in September 2017, which was highest in Maharashtra in 2017. Best College Award by SPPU Pune in year 2017. Contribution in availing UGC, DST, FIS, DBT, UGC, BSR grants from the various apex bodies of MHRD. Initiative to start skill-based BHOG programs at college campus. Establish competitive examination guidance cell, central instrumentation facility, weather station, GIS laboratory, energy laboratory, virtual learning center, e-learning facility, and Wi-Fi campus. Sir plays instrumental role in establishing PhD research centers in the various subjects like chemistry, physics, zoology, botany, economics, commerce, Marathi, English, environmental science, microbiology. Academic and administrative responsibilities. College organized UGC sponsored orientation programs, refresher courses, faculty development programs in various disciplines. Organize international, national and state level conferences, seminars, workshops. Principals Conference sponsored by UGC and Savitribai Phule Pune University. Director of CAP programs of Savitribai Phule Pune University, conducted by college. Organized CAS programs for Nashik district. College achievements. College achieved 6 times general championships of sports of university, best NSS unit, best program officer, best volunteer awards of university, best board of students, welfare unit, best coordinator, best volunteer awards of university. Third phase of CP, second level of DST, FIST, and second stage of DBT. Collaboration and linkages established at national and international level. Department of Organic and Bioorganic Chemistry collaborated with University of Graz. Austria research collaboration. One student got opportunity to work in Austria for 1 year under fellowship of Government of Austria. Department of Sociology collaborated with University of Sussex, England. Memorandum of Understanding with Electronic Science Department of University of Taipei, Taiwan. National Chemical Laboratory, Pune, for literature search and analytical data. Countries visited for presentation of research work. Sir visited different countries like England, China, USA, Sweden, Switzerland, Dubai, New Zealand, Hungary, Thailand, Singapore, Austria, Belgium, France, Italy, and etc. for the presentation of research work. Fellowship and membership of academic and professional bodies. Sir is life member of Indian Science Congress Association, Kolkata. Life member of Indian Association of Nuclear Chemists and Allied Scientists, Mumbai. Life member of Indian Association of Chemistry Teachers, Mumbai. Life member of Indian Association of Analytical Chemistry. Life member of Indian Society of Analytical Scientists. Associate member of Research Journal of Chemistry and Environment. Member of Principal Forum, Maharashtra State. Research projects. Sir, 5 research projects are completed, out of which 2 projects are sponsored by Savitribai Phule Pune University, Pune, and 3 projects are sponsored by UGC, Government of India, New Delhi. With this brief introduction, I request to Honorable Principal Dr. V.B. Gaikwad sir to guide us on green and clean chemistry. Thank you very much. Over to K.K. Jadhav sir.
Thank you very much, sir, for briefing us regarding V.B. Gaikwad sir. Now, may I invite Dr. Gaikwad sir to start his lecture on green chemistry. Please, sir.
Thank you, Mr. Sonone, for very elaborative introduction. The management representative, Dr. Amrutji Pailwan, the principal of Swami Muktanand College, Dr. Goswami. Before this session, the first speaker, Professor Deepak Kumar Rawal, who has given the very nice presentation, especially in terms of the ionic liquid and his mastery in this particular field, green chemistry. I really congratulate him. The organizer of this national webinar, Dr. Vivek Patil, Mr. K.K. Jadhav, IQSC coordinator, Mr. Ajay Tribhuvan, all the faculty members of Swami Muktanand College and participant friend. First of all, I would like to express my sincere gratitude to organizing committee, as the committee has given the opportunity to speak on this particular topic, that is green chemistry, an innovative approach for the sustainable development. I think Professor Rawal had already elaborated the different points which are very much related to the ionic liquid, because his specialization in that field, it's not my specialization. Therefore, somehow I am going to speak in general about the green chemistry, there may be the possibility of some repetition, especially the 12 principles of the green chemistry, which is universally applicable for all the different types of the subject as well as the faculty. The chemistry is playing an important role in achieving a sustainable social progress on Earth, or evolution on Earth, or the civilization on Earth. I think it's a well-known thing. Green chemistry has evolved in 1991. And after that, or during that period, means the last decade of this year, 20th century, industry people and government has adopted the green practices. Now, most of the universities has already introduced or incorporated the concept of the green chemistry in regular curriculum. But at the same time, maximum research across the world is going on in this particular field. Government as well as the industry people have taken a lot of initiative to explore the content of the green chemistry by different ways, using or with the help of the different stakeholders also. Now, the green chemistry is also called as the benign chemistry, means kind-hearted chemistry. Or green chemistry is also called as the sustainable chemistry. Now, the green chemistry, this is the definition of the green chemistry, but we'll see by different way. The use of the chemistry, techniques and methodologies that reduce or eliminate the use of generation of feedstocks, products, byproducts, solvent, reagent, etc., that they are hazardous to human health or the environment. This indirectly green chemistry to prevent the pollution before it happens, rather than cleaning up the mass later. Or we can say like this, saving money by using less energy and safer chemicals, thus reducing the cost of the pollution control and waste disposal as well as the species. And third important point is to eliminate the hazard rather than just preventing exposure. Now, this is also a well-known thing that every human being is the part of the environment. Therefore, the status of environment and quality of life is completely depend on how we means human being, interact with the environment. And that we can elaborate using the green chemistry as one of the important tool. Therefore, first aspect of the green chemistry is the green chemistry education. It's our duty to disseminate the knowledge about the green chemistry to the student as well as the society or the different stakeholder in such a way that each and every human being will be well versed with the different techniques of the green chemistry as well as the different aspect of the green chemistry, different principles of the green chemistry, and different applications of the green chemistry. Once all the human beings as well as the students are completely aware about the green chemistry, then initially you can develop the reaction using the green chemistry at laboratory level, and same reaction you can explore at the larger level in industrial level. Therefore, the industrial ecology is equally important. I know the ecology is a very famous famous word in the environment, which signifies that the relationship between the living organism and the environment. And that ecology can be divided into three parts. That is a landscape ecology, population ecology, and behavior ecology. Why these three are important? Because when the reaction is completely explored at the industrial level, then the sources of energy are different. It may be natural source, it may be artificial source, whatever it may be. But the prevention or the conservation of the source is equally important. That's why it's necessary to study this type of the industrial ecology. And if the industry people, students, faculty members are well aware about this industrial ecology, then and then we can sustain environment point of view, the particular system. And I think it is our main goal. Main goal to sustain the environment in such a way that it should be pollution free, it should be solvent free, it should be the waste matter or the different types of the waste product free. Means green chemistry lies at the heart of the industrial ecology. In short, before studying this 12 principle of this green chemistry, we'll consider about the sustainable design criteria, which depends upon the first one is the waste minimization at source, then the use of catalyst, then using the non-toxic reagent, use of renewable sources, then the improved atom efficiency, and finally use of solvent-free or recyclable environmentally benign solvent system. As far as waste minimization at source means, everybody should be well aware or should take the precaution. There must be the minimum waste or 0% waste after completion of the reaction. Now, for the use of catalyst in place of reagent, means instead of reagent, if you give the proper preference to the catalyst, then what's the benefit of the catalyst? That we can clarify through the definition of the catalyst, which is the substance that increases the rate of chemical reaction without itself undergoing any permanent chemical change. Means the catalyst cannot take the part in the particular reaction with the help of the reactant. And if you give the preference for the catalyst, then there is no need of the reagent also. Same case is applicable for the third point. The researchers should give the priority for the non-toxic reagent. Means the compound should be free from the toxic element or the toxic reagent. Then the fourth one is the use of renewable resources. A renewable resources is one that can be used repeatedly and does not run out because it is naturally replaced. A renewable resource essentially has an endless supply. Therefore, the conservation of these renewable resources or the use of the renewable resources is a very important as far as the green concept, green technique, and green chemistry is concerned. There are very famous examples of the renewable resources like the solar energy, wind energy, or the tidal energy, then geothermal energy, or biomass energy. These are the different examples. Along with that, if you adopt the green chemistry, then or green technique, then you can find out the different types of the renewable resources to carry out the different chemical reactions. I think improved atom efficiency, which has been already explained by the Rawal sir. I'm not going to explain in detail, but atom efficiency means what? the maximizing the incorporation of material from the starting material or reagent into the final product. It is essentially pollution prevention at the molecular level, because which can be converted into the atomic state. Or the formula for the atom economy or the atom efficiency is given as the mass of atom in desired product at the numerator side divided by the mass of atom in reactant at the denominator side multiplied by 100. And if the mass of atom which are present in the reactant, suppose converted into the desired product, then the atom economy tends to 100% or around 90, 98, 99%. Therefore, this improved atom efficiency is one of the important aspects of the green chemistry, which is responsible to clear the atmosphere also. And last one is the use solvent-free or recyclable environmentally benign solvent system that we'll see in the next slide. Now, what is actual need of the green chemistry? No doubt, it's a very prominent part of our daily life. Chemistry is a very prominent part of our daily life. Then what is need of the green chemistry? To clean the air, then less release of the hazardous chemical to air, leading to the less damage to the lungs, increased safety for workers in the chemical industry, then less use of toxic material, less personal protective equipment required, and less potential for the accident. That's why the green chemistry is a very much essential. In addition to that, day by day, there is the development in the different chemical reaction and which are responsible or which can create the different types of the problem of the environment also. And that is also harmful, having the unexpected side effects and which result in the need of the greener chemical product. Therefore, to avoid this unexpected side effect, harmful side effect, or to create the different types of the environment problem, the greener chemical product is a very much essential. And third one is, I think most of the participants are completely aware that the DDT is completely banned. I will quote here the famous example is the pesticide DDT. That event or that instant was happened in Kerala, and most of the people or most of the human beings suffered with the inhibited gene mutation. Therefore, the chemical can create the different types of the problem for the human being. But if you prefer the green chemistry, then that will remain beneficial for the human being as well as the environment. Now, this green chemistry always can be considered in terms of the solvent-free or the atom efficiency or the atom economy also. This green chemistry program always support the invention of more environment-friendly chemical processes, which is responsible to reduce or even eliminate the generation of the hazardous substances. And this program worked very closely with the 12 principles of the green chemistry. Friends, whenever you are thinking about the green chemistry without 12 principles, you cannot explain the green chemistry very in detail about the green chemistry. Already Rawal sir has explained, and in short, Mr. Ajay Tribhuwan has also explained about the 12 principle. But I am going to explain in terms of what is meaning of that particular word. The first one is the prevention, means the waste prevention. Means the priority should be given for the prevention of the waste rather than the cleaning up and treating waste after it has been created. Therefore, it's necessary to plan for minimum waste at every step. The second one is the atom economy, means reduce waste at the molecular level, means molecule will be converted into atom by maximizing the number of atoms from all reagents that are incorporated into final product. Use atom economy to minimize waste at every step. I am also going to explain in detail about that particular example. For example, the Diels-Alder reaction, that is the cycloaddition reaction. It gives the 100% product, no side product. Means what? For example, A plus B, these two are the reactant, which will be converted into C. It's only one product. And this one product signifies that they are successful in the atom economy. Then the hazardous chemical reaction, less hazardous chemical reaction, means your chemical reaction should be designed and synthetic route should be very safe as possible. Consider the hazards of all the substances handled during the reaction, including the waste. The very famous example, that is the Friedel-Crafts reaction. I am also going to explain in detail about that, because the aluminum chloride or the BF3, that is boron fluoride, having the hygroscopic nature, which catch fire, as well as the product will be converted into the aluminum chloride will be converted into OH thrice, and which is responsible to enhance the waste product. To avoid that, we'll give the preference to the nanomaterial. That I will explain afterwards. The design safer toxicity by such as the physical properties, toxicity, and environmental fate throughout the design process, which is also very important. The next one is the safer solvent and auxiliaries. Choose the infinite solvent available for any given step. Minimize the total amount of the solvent and auxiliary substances used, as these make up a large percentage of the total waste created. The next one is the use of renewable feedstock, the design of the energy efficiency. Choose the least energy intensive chemical route by which we can avoid the heating as well as the cooling as well as the pressurized and vacuum condition. That means the reaction will be possible at ambient temperature and the pressure which are optional there. Then the use of renewable feedstock means use the different types of the chemical which are made from the renewable, whether it is from the different renewable sources or the plant-based sources, rather than other equivalent chemical originating from the different petrochemical sources like diesel or the petrol or any other sources. Then the reduce derivatives. Minimize the use of temporary derivatives such as a protecting groups. Then avoid the derivatives to reduce the reaction step, the resources required, and the waste created. Same case is applicable for the catalysis. Use catalysis instead of the stoichiometric reagent. Choose catalysis to help increase in the particular reaction selectivity, minimize the waste, and reduce the reaction time and the energy demand. That I have already explained here. Then design for the degradation. The product should be like this, which would be degradable. Design chemical that degradable and can be discarded easily. Ensure that both chemical and their degradation products are not toxic, bioaccumulative, and environmentally persistent. Then real-time analysis for the pollution prevention. Monitor chemical reaction in real time as they occur to prevent the formation and release of any potentially hazardous and chemically and polluting substances. And last one is the safer chemistry for the accident prevention. Choose and develop chemical procedure that are safer and inherently minimize the risks of the accident, know the possible risks and assess them before handling. I think these are the 12 principles of the green chemistry which is really important, and using the different example, you will get the maximum idea about that 12 principle. Now, along with that, the green chemistry techniques are equally important. Now, what is actual meaning of the green chemistry technique? Green techniques include the reaction of carbon and hydrogen bond, activation, fluorus, then solid supported, bio and asymmetric catalysis and synthesis, use of the water, other green solvent. I think Professor Rawal has also explained about the microwave and ultrasonic reaction. Therefore, there are the different examples of the green technique like reaction in alternative solvent. Very famous example, he has already explained about that, ionic liquids, because ionic liquids are the molten salt of the organic compound. Then the atom economic multi-component reaction that I'm going to explain in detail. Then third one is the microwave and ultrasonic reaction, is to save the time and to accelerate the reaction more faster. The microwave as well as the ultrasonic reaction technique plays a very important role. Or microwave and ultrasonic reaction are the new techniques by which we can save the time, energy, and accelerate the reaction more efficiently to achieve the high yield or more percentage of the yield. Of course, without any solvent, you can carry out that particular reaction. And last one is the flow reaction, is to design the flow techniques for chemical reaction in pharmaceutical industries to save the time, again energy, and minimize the waste generation. But using this technique, the synthesis of nanomaterial using the green catalyst and solvent would be possible. There are different applications of the green chemistry. The first very famous example of this very famous application of the green chemistry, the use of the auxiliary substances, for example, solvent, separation agent, etc. Means there is no need of that wherever possible and innocuous when used. This is a solvent-less reaction. Means there is no need to use any kind of the solvent. Solid A plus solid B after reaction or after grinding, it is converted into solid C, and which can give the maximum yield. For example, here you can see the aniline is one of the reactant, and second reactant is the aldehyde. Without using any solvent like ethanol, methanol, or any solvent, which can be converted into the product like imine or the skip base. And this is completely greener approach. In the same way, you can develop the different types of the reaction which are related to the different aromatic aldehyde. This is one of the example of the green chemistry which can save the time, save the economy, but which is also responsible to save the environment also. Another example, that is a Friedel-Crafts acylation reaction. I think up till now means up to 91, 92, we have seen every time the Friedel-Crafts reaction with the help of the Lewis acid. For example, AlCl3 or the BF3. Now, in case of the Friedel-Crafts reaction, generally require Lewis acid to promote the reaction using the AlCl3 or BF3, which are highly hygroscopic, therefore difficult to handle, as well as it requires the tedious process to decompose of a reaction which generates is the AlCl3 converted into aluminum hydroxide plus HCl. And because of that side product, we cannot prevent the atmosphere or the environment which is responsible to increase the pollution level. Now, instead of that, if you prefer the nanomaterial like zinc oxide, and of course, that is over the acylation reaction is the new catalyst like the zinc oxide. And here you can see that particular reaction. The benzoyl chloride reacts with the anisole in presence of very less amount of the zinc oxide, that is a 0.5 equivalent. Of course, it is a nanomaterial, and the required time is from the 10 minutes to 2 hours, and which can be converted into the benzophenone, means only one product. And this one product signifies that this is just like the ionic liquid reaction. The one more example, which is related to the Merck's green chemistry. And this is a very famous Merck green chemistry strategy, which led to highly efficient waste reducing cost cutting synthesis for converting inexpensive raw material into antiviral drug, for example, like Letermovir, using the hydrogen bonding chiral bistriflamide organocatalyst. Towards the left-hand side, you can see the different types of the reactant. We have already maintained the different types of the aspect of the green chemistry, means this reaction is designed for the atom economy because the molecular levels are converted into the different types of the atom. Then invent new transformation, of course, that you can see in terms of the product. Then priority is given for only one route. Select route means only one route is here. And the same reaction is optimized for the sustainability. Therefore, this reaction is called as the one-pot multi-component reaction, which is converted into the Letermovir, which is only one product. And this product is the antiviral drug and is for the treatment of the cytomegalovirus infection. What is the benefit of this reaction? The combined improvement increase the product like the Letermovir's overall yield by more than 60% and reduce the raw material cost by the 93%. The researcher estimate that optimized process will eliminate more than 15,000 metric ton of waste over the lifetime of the Letermovir. Therefore, it's a benefit of this green chemistry which is used by the Merck's and which is known as the Merck's green chemistry. Then another example of the green chemistry or application of the green chemistry, here you can see the synthesis of 1-amido-alkyl 1,2-naphtol under green condition, which is developed by one of our research students, that is N.K. Jadhav, in collaboration with another researcher from our college, that is Dr. R.R. Kale. Now, in this reaction, you can see the different reactant. The first one is the beta-naphthol. The second one is the aromatic aldehyde. Third one is the acetamide, benzamide. And fourth one is a very important, that is a ionic liquid. I think Sir has already explained about the ionic liquid, which is defined as a salt with melting point below the boiling point of water. The ionic liquid, also known as the neoteric solvent, designer solvent, ionic fluids, and molten salt. And most of the ionic liquids are composed of the organic cation and inorganic anions. Then using that ionic liquid, you can see here the product, the product like 1-amido-alkyl 2 naphthols, having the yield is in between 85 to 90%. Means indirectly, there are a lot of application here. The general statement is given for the pharmaceutical application. The most simple and direct way to apply green chemistry in pharmaceutical product, and of course, our aim is the reaction must be eco-friendly, non-hazardous. There must be the reproducibility, then efficient solvent or no solvent, and the catalysis in synthesis of the drug molecule. For example, the flow technique you can use, or the enzyme mediated reaction, then the fermentation process, and the environmentally benign catalyst. These are the different examples to carry out the different pharmaceutical reaction in industry as well as the laboratory. Now, considering these, some of the examples of the application of the green chemistry, one should be very much aware about that. You can use the raw material feedstock, which should be renewable. Whenever you are going to consider about the green chemistry, the renewable, this word is very important, because if there is the renewable rather than the depleting, wherever technically and economically practical. For example, here, towards the left-hand side, the one of the non-renewable source means, for example, the nuclear plant, which is always depleting the level of the radioactive material from the earth crust or from the earth. Then there is no green technique for this type of the non-renewable sources. There may be the possibility of the maximum pollution in the laboratory as well as in the environment because of the non-renewable sources. In contrast, according to different principles of the green chemistry, if you consider the renewable sources, then you can save the time, you can save the economy, you can curtail the different types of the pollution level. Here I have shown the one example that is from the sugar factory, the bagasse or the biomass, we can use as one of the energy source. Therefore, instead of the non-renewable sources, according to green chemistry, the maximum priority should be given to the renewable sources. Here you can see the different application or the example, that is the polylactic acid for the plastic production. In this case, the fermentation process is carried out through the corn, which is converted into starch and unrefined dextrose. Initially, the lactic acid is present in the monomeric form. And then it is converted into the polymeric form or the polymer production. And finally, it is converted into the polylactic acid. And then it is, after modification, it is converted into the polymer modification. And finally, you can see the different types of the plastic material. Now, this method is a very good as far as green chemistry is concerned, because whatever it may be the products, all those products are the biodegradable. Therefore, which is not responsible to enhance the pollution level of the environment. Means indirectly, if you give the preference for the fermentation process, means formation of the lactic acid using the corn, then initially it is converted into monomer form, then it is converted into the polymeric form, and finally it is converted into the PLA. The same case is applicable for the, another example is the polyhydroxyalkaloids, where the sugar solution is prepared, which get fermented to get the polyhydroxyalkaloids, and which can be used for the plastic product or the, here you can see the plastic product. The stepwise the crop plus sunlight converted into sugar solution, and after fermentation, it is converted into the PHA, that is a polyhydroxy alkylate. What is the beauty of that reaction? The plastic product is the biodegradable. And after biodegradation, which is converted into the greenhouse gases like the carbon dioxide and H2O. Therefore, this reaction is equally important here. Friends, here, as I have already explained about that, the most of the reaction carried out in presence of the nanomaterial, because the required amount is a very less, and which is not responsible to enhance the pollutant level. Therefore, most of the time, nanomaterial used as the nanomedicine with green synthesis. Here, in this particular table, you can see the different types of the nanomaterial you can prepare using the different types of the plant extract or different material. In the second column, here you can see the clinical use, and in the third column, that is the green synthesis. Means you can prepare the gold, silver, iron oxide, zinc oxide, and carbon nanotube nanomaterial using the various plant extract or different material using the green chemistry or green synthesis formula from the plant extract or from bacteria, then almond leaves tannic acid, or from tea leaf extract or the bacteria, from plant extract, and finally the using camphor or the biodiesel. What's the actual use as far as gold nanomaterial concerned? The clinical use for the cancer therapy and the diagnosis, for the silver nanomaterial, that is the antimicrobial activity. After synthesis of the iron oxide, which can be used for the MRI contrast and the diagnostic purpose, the zinc oxide, antibacterial activity, and for the carbon nanotube, means synthesis of the carbon nanotube, we can use for the toxicology studies as well as the diagnosis of cancer and the use of that material for the cancer therapy. Same case is applicable for the different types of the using the plant extract. For example, the tea leaf, then Emlica, Ophinylase, then third one is the edible mushroom, and fourth one is the Tamarindus indica. Now all these different types of plant extract is responsible for the green synthesis, means the synthesis of the gold nanoparticle. Same case is applicable for the silver nanoparticle, and here the different sources of the plant extract as well as honey has been given, like the almond leaves, then the aloe vera, tannic acid, and honey, which can be used for the synthesis of the silver nanoparticle. Here I am going to explain the one of important catalyst, which is known as the TAML, that is the tetraamido macrocyclic ligand, which has the tendency, this is one of the catalysts. This catalyzes the degradation of the pesticide, which can be used for the effluent from the paper mill at ambient condition, which can be function at broad range of the pH from 1 to 13, which is also possible at very less amount of that particular compound, that is 0.1 to 4 parts per million. Therefore, this particular catalyst can be used for the to carry out the reaction, different types of the chemical reaction, especially the prototype exhibit versus low toxicity. Then it's a very easy to synthesize the different types of the product. It's a water soluble, I have already explained about you can use the wide range from 1 to 13 pH. Then, which is also used by the different scientists across the world. Therefore, there are right now 10 years patent and more than 70 counting foreign nationalization. This is effective because minimum amount is required to carry out the reaction from 0.1 to 4 parts per million. Then I think you might have heard about the Pike research, which is a very famous research. And this research is one of the part of the green chemistry, because the green chemistry is expansive discipline, not expansive, means which give the broader level of the different types of the reaction. Means the green chemistry, especially in case of the Pike research, is an expansive discipline that is evolving in response to this wide array of the challenges. And according to new report from the Pike research, which represent a market opportunity that will grow from $2.8 million in 2011, which already reached up to the $98.5 billion by 2020. And they have given the different types of the application in terms of the enzymes. Means enzymes used in many chemical reactions to synthesize the different types of the drug molecule. Then enzymes are also useful in resolution process, which saves the cost and minimize the chemical waste generation in the whole process of the chemical reaction. For example, the sulfonation, a drug which can be used in the urinary infection treatment. And another example, that is the peptide-based drug molecule using the different types of the enzyme. Friends, these are the different example or the application, but what is the need of the time? Therefore, there must be the very specific strategy, and different type of the strategy should be integrated to explore the different types of the green chemistry. Because right now, most of the colleges, most of the universities, or most of the researchers are giving the more emphasis on the brown chemistry. Now it's our duty, it's a duty of the university, it's a duty of the college people. Instead of brown chemistry, most preference should be given to the green chemistry. Now, one more suggestion is the green chemistry should become the integral part of the curriculum. Then and then, we can accept the different types of the challenges of the pollution and the perspective of the different types of the pollution. I think as far as the Pune University is concerned, the university has already initiated the micro scale level organic reaction. That is also one of the part of the green chemistry, because in case of the micro scale kit, we are using the minimum amount of the chemical to carry out the different chemical reaction. Or the Department of Science and Technology have given the different types of the technique which can be useful for the physical chemistry. For example, right now we are using the potentiometer, calorimeter, pH meter, or different types of the equipment. But that particular Department of Science and Technology have given the very cheapest techniques to carry out the reaction instead of using these type of the potentiometer or the calorimeter or these the conductometer, etc. Now, if you go through this document of the Department of Science and Technology, you will get an idea about that cheapest technique. And if you adopt that technique and implement at our laboratory level, then of course that will remain beneficial for the college, as well as the student, as well as the faculty member, and indirectly that will remain beneficial for the nation also. Means indirectly, first of all, accept the challenge and give the solution in terms of the green chemistry to carry out the different reaction as well as the different techniques. Friends, it's necessary to change the mindset and apply the green concept not only for the industry, but apply that green chemistry concept in the classroom. For example, you can use the light emitting diode, means the LED tube is one of the example of the green chemistry. Then for the laboratory, I have already explained about the micro scale technique. Then the manufacture and the surrounding environment means it's a duty of all the faculty members to disseminate the knowledge of the green chemistry to industry as well as the different types of the stakeholder also. Now, the second point is important, very important nowadays. The Google as well as the other resources can give the idea of green chemistry. Therefore, indirectly, students are well acquainted with the green chemistry. And if you consider the input of the student, and if it is incorporate in the regular curriculum through the board of studies, through the faculty, then that will also remain beneficial for the society also. Now, the modernizing the curriculum using the latest green chemistry development means what? Most of the time during the revision of the curriculum, we never think about the modern curriculum or the modern syllabus. Now, this is the need of the time to save the earth, to save the environment. It's a need of the time to adopt the modern curriculum, though it belongs to the Western country or the other country, but our faculty members, it's a need of the time to accept this type of the curriculum. And finally, replace rather than the adding course material. Replace means there should be the direct replacement. If it is integral part of the curriculum, that is the green chemistry, then and then the maximum benefit will get the student. In continuation of that, I would like to explain about the laboratory level as well as the industry level. Means finding the experiment that illustrate the green chemistry concept and are effective in the teaching lab. That I already explained. But in this pandemic situation of the COVID-19, it's a very necessary to develop the interactive teaching in it, just like the augmented reality or the virtual reality. I think using the concept of the augmented reality without using any chemical, you can carry out the reaction. But for that, the maximum effort should be taken by the faculty member to introduce that type of the curriculum, not only curriculum, but to enhance this teaching learning process for the benefit of the undergraduate student in terms of the green chemistry. And finally, the encouraging chemistry student to consider the principle of the green chemistry when designing the process and choosing the reagent. For example, when you are going to conduct the different types of the experiment in laboratory, then your mindset should be like this: that particular reaction should be developed in such a way that the concept of this green chemistry will be introduced in that development of that particular reaction. And considering this point, I would like to explain different points which are very important as far as the green chemistry is concerned. We are not very much concerned about the emitting legislation in favor of green chemistry, which is the in purview of the government, and government is taking the lot of care for that particular. This is my suggestion. The award should be given for the green chemistry user. Then grant should be given for the green chemistry research, maximum grant should be given for the green chemistry research, chemistry researcher, as well as the development of the green chemistry concept. Then it's our duty to develop the educational activity in green chemistry as well as to organize, just like this particular college has already organized this type of the conferences. In the same manner, the different types of the conferences as well as the work for the green chemistry is really very much essential. Then it's our duty to establish the good relationship with the Environment Protection Agency, and finally helping others learn from our experience. That is also important. Here you can see the pollution prevention hierarchy, which is the well-known hierarchy, that is the prevention and reduction, then recycling and reuse, then the treatment, and finally disposal, which is not limited for the chemistry as one of the subject, but which is universally applicable for all the different types of the subject, including the physical sciences, chemical sciences, life sciences, and mathematical sciences, which is the universal formula or the triangle, that is the prevention and reduction, recycle and reuse, treatment, and finally the disposal. And finally, the conclusion of this particular lecture is the success of green chemistry depends on the training, how the students are trained, how the faculty members have acquired the knowledge about the green chemistry of the new generation, means to disseminate that knowledge to new generation of the undergraduate as well as the postgraduate student in the chemistry. And second one is apply the green chemistry education should build on understanding the need of the chemical industry, because if you train the student at the laboratory level, and once the student acquires the knowledge of the green chemistry at the laboratory level, same type of the knowledge will implement the student at the chemical industry or the pharmaceutical industry. And obviously, because of that, the yield or the product of these chemical reactions will be increased. Therefore, friends, to prevent the pollution before it happens, which is also one of the principles of this, the green chemistry, then save the pharmaceutical companies using the less energy, fewer and safer chemical, thus reducing the cost and impact of the pollution. Third one is a very important, that is a make less severe, means the mitigating. Less severe climate change, water and resource depletion, and growing demand for safer products and cleaner energy. And finally, green chemistry is not a solution to all environmental problems, but the most fundamental approach to preventing the pollution. Therefore, my humble request to all the faculty members as well as the participant, each and every faculty member must acquire the different skills which are required to carry out using the green chemistry. And it should not be limited for the faculty member or the participant, but all the faculty members should disseminate the same knowledge to others also. Other means all the stakeholders as well as the industry people also. Right now, there is no strong interaction between the industry people and the academician. And it is a duty of the academician to impart the knowledge, which is a very much required for the industry people, in effective way. Then and then, I think this type of the seminar will remain fruitful for all the stakeholders. Thank you so much. I would like to express again my sincere gratitude to organizing committee, as the committee has given the opportunity to deliver the knowledge which is very much essential for the green chemist. Hope that this type of the national seminar will remain one of the milestone for this Swami Muktanand College, Ula. And I hope in future all the faculty member as well as the student will take the initiative to explore the knowledge of the brain chemistry. Thank you. Thank you so much.
Thank you, sir. We are immensely thankful to you for giving this informative lecture on green and clean chemistry. During your lecture, sir, you asked to adopt the 12 principles of green chemistry, and especially nanoparticles, its use, its extraction. This information will be more useful for me, for us, and all faculty members. Thank you, sir. Any question from participants, sir?
Sir, Patsore, sir.
Patsore, sir, is going to ask questions.
Sir, I would like to ask one question to our today's eminent personality, Dr. V.B. Gaikwad, sir. Sir, we know wastewater contains a large amount of waste or chemicals that comes from the effluents from different chemical industries mostly, and it mostly contains the phosphorus. Large amount of phosphorus is there. So, sir, is there any material that only absorb the phosphate from the wastewater?
Any material?
Which absorbs the phosphorus only from wastewater.
Okay. Then what's the question? Any material?
Is there any material that only absorb the phosphate from wastewater?
Phosphate from that wastewater? No. For to remove the phosphate, there are two or three different methods. As you belongs to botany, then let me explain with respect to the bioremediation process. Actually, the phosphate, more amount of the phosphate is responsible to destroy the fertility of the soil. And therefore, for the bioremediation process, the first important one is the phytoplankton. Therefore, you can use the phytoplankton. That phytoplankton has the tendency to absorb the excess amount of the phosphate. That is the one point. If you consider the water pollution and the phosphate, then the another alternative is the recycling is a very important. But because before the recycling, the treatment is a very essential. But to remove the phosphate, there are some material, is the porous material, which has the tendency to adsorb, not absorb, adsorb that phosphate. But that process is a very tedious, and we chemistry people always use the chromatography for that particular process. But that is the time consuming one thing. Second thing is it is not economy saving. Instead of that, if you give the preference to the recycling, using the converted that phosphate into the fragmentation, is the molecule is converted into the atomic state, then and then you can remove that phosphate. And as far as soil is concerned, the phytoplankton is one of the important tools to remove the phosphate from the earth, the soil level.
Thank you, sir. Thank you. Thank you very much.
Is there any question from audience? Is there? I think there is no question from my participants. Thank you, sir, for giving nice informative lecture since last 1 hour. Now, turn to us last quadrant of this webinar, that is vote of thanks. I would like to invite Dr. Vivekji Patil to give vote of thanks on this occasion. Vivek Patil, sir.
Hello. Hello.
Yes, you are audible, sir.
Yes, audible, sir. Please, sir.
Okay. Good afternoon, everyone present here. Sri Gurudev Shikshan Prasarak Mandal Yevlaj, Swami Muktanand College of Science, Yevla District, Nashik, and Department of Chemistry has organized a national webinar on green and clean chemistry. Behalf of the college and Department of Chemistry, I am here to propose vote of thanks to our guests for giving their valuable time and for enlightening us on green and clean chemistry. First, I would like to thank Principal Dr. V.B. Gaikwad, who is ex-BCUD Director of Savitribai Phule Pune University, Pune, and Principal of KTHM College, Nashik, for sharing his knowledge on green and clean chemistry. I would also like to thank Dr. D.K. Raval, Professor, Sardar Patel University, Vallabhnagar, Anand, Gujarat, for his elaborated speech on green and clean chemistry. I would also thanks to our principal, Dr. D.B. Goswami, for his guidance and direction for conduction of this program. Also special thanks to our chairman, Dr. Amrutsa Palwan, Secretary Sri Deepak Gaikwad, and entire management for their encouragement and cooperation for successful execution and planning of this webinar. Last but not least, I will also like to thank our enthusiastic participants, especially our ex-student participated from USA, Germany, and Czech Republic. I would like to thank IQAC Chairman, Professor Ajay Tribhuvan, all the faculties and non-teaching staff of our college. Finally, I would like to thank Professor K.K. Jadhav, Head of the Department Chemistry, Professor R.K. Sonamne, Professor P.N. Patil, Sri Valmik Magar, for their cooperation throughout this national seminar. Thank you and have a nice day. Over to K.K. Jadhav.
Thank you, sir, for your lucid and placid language in expressing your view regarding this webinar, sir. With the permission, if there is no hesitation from participants, I would like to conclude this webinar if our principal permit us. Sir, sir, may I conclude, sir?
Yes,
Hello?
sir. Okay.
Yes, sir.
Oh, yes, sir. Okay.
With the permission of Honorable Principal Dr. Dhanraj Goswami, sir, I declare that this webinar is over, and we shall back once again with new subject, new webinar very soon. Till then, goodbye.
All the participants, you will get the feedback link on your email. After fill up the feedback form, you get the e-certificate on your mail directly. In 10 to 15 minutes, you will get the feedback link.
P.N. Patil, very nice. P.N. Patil, very nice.
Karaban. Are
Patil, sir.